Hi, I'm Jesse Henning, a senior VFX artist in the game industry with a background in creating gameplay and cinematic effects for AA and AAA titles, all in the Unreal Engine. I believe visual effects is one of the most exciting and rewarding roles in the games industry. It is also a role that recruiters and studios are constantly looking to fill because there just aren't enough of us out there. That's why I'm creating this course. I want to help to prepare artists to not only create visually appealing and immersive effects, but to also help them bring those effects to life by prototyping gameplay logic that can help communicate design and system needs with other disciplines in a production. This is a massive course that will exist in 3 separate parts. Each will build on the other. The first part, we will create our respawn and ammo pickup effects. Those will lay the foundation for part 2, where we will move into our weapons effects. We'll create laser blaster effects for our character and enemy turrets, as well as a predator-like plasma blaster for our character. Finally, we'll wrap up in part 3 with an energy shield and a pulse grenade, exploring more advanced materials and more technical Niagara system techniques. In each part of this series, I will go through creating and using concepts to plan and prepare for creating our effects. Then we will create any external assets like our meshes, textures, and simulations and bring them into Unreal. We will build simple to complex materials from the ground up to give us greater control over art direction and functionality. We'll also use blueprints to craft all the functionality for our effects. We'll dive into the character blueprint actors for effects animation and functionality, and use child blueprints for controlling iterations of our effects with custom properties that we can manipulate. Finally, we will compose our effects in our Niagara systems and create satisfying timing and visual communication for gameplay. We'll be using Blender, Substance Designer, Houdini, Embergen, and Unreal 5.1 or later for this course. If you do not have access to some of the paid programs, I've made all of the assets available along with the base engine for use in this course. This course is for more advanced beginners and intermediate level students and will assume you have some basic understanding of Unreal and the programs used. My hope is that by the end of this series, you will have a greater set of tools and techniques at your disposal for crafting and prototyping effects in a production environment, and that you will be able to create a stunning portfolio to help you land that dream job as an effects artist, or at least take your career to the next level. I'm excited to share some of what I've learned from my time in the games industry, especially while using the Unreal Engine. So join me and let's start crafting. All right, in this video, I want to actually go through my process during a production. So I've shared this document with you. It's called my VFX production process and pipeline. And these are just the steps that I take throughout each time that I create an effect. So I wanted to share this with you in case this is helpful and beneficial for how we're going to move through. I'm also going to explain how we're going to move through this entire course and what we're going to cover within this document and what I'm going to leave out, and just understand that it is a part of my process, but you won't necessarily see every part. Otherwise, this course would be even more massive, and there are some things in there that just aren't necessary for me to show. So if you look, the very first thing that ever happens with effects is you go into a brief or you get a task assigned to you, and then there should be some kind of description that determines the gameplay, art direction, who the feature owners are, meaning is it a designer, is it an engineer, is it a tech artist, or is it you as an effects artist that is holding the key to this feature and that you're the one responsible for it. Also, this will allow you to kind of collaborate within your departments and to understand who is going to be responsible for what section of implementation and gameplay needs so that you can work interdepartmentally with others. Then I would go into my reference. So after the task is given, I'm going to go into my reference and you'll see kind of my process. Basically, I'll go through any online videos, I'll Google images, I'll find maybe articles or books that I have in my library and take snapshots and basically gather reference of what kinds of elements I want to pull into my effects so that I can have a better understanding. And I want to pull from a lot of different places so that I don't rip anybody off or copy something verbatim. But I will then put all of that in a board through a program called PureRef, which is a free app. And you can go right here on this website, and you can either give money towards the development of it, or you can grab it for free. But it is an amazing tool for organizing images. So here in front of us, I just have a sample board of images I collected while I was working on this course specifically. And most of the time I have a lot of images and reference and all sorts of things. Now this is good for pictures, but I'll also gather YouTube videos and put them in a playlist or find videos elsewhere and try to either do screen grabs or record little snippets of them, put them in a timeline and edit that together so I have some reference of what I'm looking for. And then also looking at, even scientific things. As I've studied explosions, I was looking at what kinds of explosions use powder and what does powder do when it ignites versus fuel like gasoline, things like that. So it's good as you're referencing to kind of gather all of these elements together. Then moving into a concept, I have received concepts from concept artists. I have made my own concepts throughout the years. And basically, this is a huge advantage. I don't always do this. I'll be completely transparent. I don't always concept. I don't always have time, and concept artists don't always have time. So there are times when I've done an effect so many different times before, and through all my referencing, I'm able to pull together elements. But the more you concept, the more you create a visual representation of what you're going to be doing, the better everyone is clued into the visual target of what you're trying to hit, and it allows you to get approval from art direction a lot faster. So concepts are really key. As much as you can, produce a concept or create some sort of visual so there's a visual language, a visual target for you to hit, and to allow everybody to kind of get on board with you in your concept phase to know how you're moving forward. Then I go into R&D, which is researching my tools, techniques, workflows, and tech to develop my pipeline and workflow for creating my effects. And basically, I'm going to be seeing, okay, is there something new in Unreal? Is there a new tool out there? Is Houdini added more labs plugins? What are some workflows that I could use to my advantage? What kinds of things can I explore around some of the workflows I already know and use that to bring into my effects and craft something new? So as much as you can have time to do some R&D, I highly recommend it. And then this is where I'll also start my documentation. So you can see documentation kind of runs throughout the rest of the process. I use Confluence, even personally, I use Confluence. Most of the studios I have been to use Confluence online. It is free if you're just by yourself, and it's a phenomenal way to put videos, GIFs, pictures, and then a lot of text, link tutorials, link videos, all sorts of things to allow you to document, break down your process. And I highly recommend documentation because there are things that are so niche to a certain type of effect that later you will come back and you'll forget how you did it, and you'll want that documentation available so that you can use it to your advantage to be able to remember something that you did a long time ago. So documentation is huge. It also keeps others informed, and it allows people to know what systems you're creating. So I definitely recommend documentation. So once I get through R&D, I'll do a block out and a test. And this is kind of a rough draft. This is where I may put some just square sprites in an emitter to see how they're bursting. I may have temporary textures already available to me, and I'll just see how those scroll through meshes to get blockouts going, experimenting with timing, seeing how some textures will play with things, experimenting with materials, and just doing that basic blockout to kind of see if I can get just a rough composition of what I'm doing. Then once I'm completely informed, my concept will also inform me into asset creation. And this is really where we're going to be starting. So that's just when we're going to create all our external assets, meshes, textures, simulations, vector fields. We're not doing vector fields in this course, but basically anything you need externally that you will bring into the engine. Then we will import these assets and test them. So I might put an explosion on a card and test the timing of it. I'm not putting it in a Niagara system yet. I'm going to stick it in a level to see how it maybe reacts to some of the lighting. I want to see the timing, some of the elements I've pulled in with my materials. And you'll notice I do that throughout the course. Maybe bring in a mesh and start testing some of the texture scrolling over the top of it. But basically I want to import, test my assets, make sure they're optimized, go through all my settings, all of that stuff. Then I'll move into in-engine asset creation, and sometimes I will go back and forth. In this course, we're going to work very linearly, but most of the time I'm doing a lot of back and forth, especially if something doesn't work right. I've spent a lot of time making sure these assets are where I want them to be for this course so that I can just lead you through the process. But just know it doesn't just happen that quickly sometimes. It is a lot of back and forth. So I will start making materials. I'll make, any material functions or curves or material parameter collections, blueprints, Niagara systems, anything in engine that we need to create for the whole of our effects. Then I'll go into prototyping logic. And again, sometimes I intermix this, and in some parts of this course, I'll be intermixing some of the blueprint logic as well. But I'm just going to build a prototype logic to either house an effect or make sure it kicks off or do a projectile test, something where I can start building some logic to test these effects and make sure they're working properly. Then once I'm done with the prototyping, which is basically where this course is going to end, because we're not trying to get this into a game, we're working in a gym, which most of the time, if you're at a studio, you'll have either an empty level or a gym or some sort of level that may have some rough assets in it, some environmental stuff, the right lighting conditions, a way for you to be able to test your assets. So basically, we're going to stop with prototyping the logic, making sure it's all playable. However, the next step would be getting it over to whoever is responsible, those feature owners, to be able to implement the effects into the gameplay design. Then optimization, you'll maybe send it off to tech art or engineering, and they will optimize your effects or tell you to optimize it. There are resources we have as effects artists to optimize our effects, so we want to be working through optimization. Then overall, once everything is optimized, we'll go back and just polish any textures, meshes, anything art direction wise that we want to just really finalize our effects, make sure they're beautiful and as polished as we can be. There is a time where you have to say, okay, good is good enough, let go of it, especially if it's not a hero asset or anything like that. So polish phase, and then the task is done after it's been signed off on. Maybe your art director is happy with it, gameplay is satisfied, it's polished, implemented, and working as intended, as well as optimized. The task is done and we move on. So that is kind of a big overview of my VFX production process, and that's kind of my pipeline. I literally do this almost every time I create an effect. So this has been a great guide for me. You may have different ways of doing things. You may be working on very stylized effects or other kinds of effects that may include some other steps in there or ways of working between them. Know that this isn't completely linear for me. Again, I will go back and forth a lot between the process and really wage the tension of making sure everything is well-timed and balanced and working. Anyway, that's how we're going to move through this course, and you will notice that pattern as we go through each one of our sections in each of the 3 parts of this course. So let's go ahead and move on so we can start making our effects, and I will see you in the next video. All right, hello and welcome to the editor. If you have downloaded the course content, you will notice that you will have an assets folder, and within the course content folder, you will have an engine folder for the actual engine that we'll be using. And you should also have a VFX assets folder, which will have all of your textures and meshes, simulations, all of the project files for the external content that we're going to be going through for this course as well. And I'm going to go through kind of a basic setup for what is going on inside of this engine, things to be aware of, things to prepare for. You should have a level that is open called Map Sci-Fi VFX that looks like this. And you'll have all of the walls, impact barriers, you have a spawn platform here, and you should also have a nice little setup for where your turrets will be. Now, these can be deleted out and you can manually place them. This is just a nice little testing area that we're going to be testing our shield effects later on for. So have that. Another thing to be aware of just right off the bat within this editor is my awesome friend who's a very talented sound designer, Brian Michael Fuller, has provided all of the score and sound design for this project, and we will be hooking that up in some of our logic later on. Some of the sound design already exists, like when you play, you will hear laser effects, you'll hear footsteps, you will also hear ambient noise and a score. And the score and the ambient noise are just dropped in the level like this. If it becomes something that you don't want consistently playing every time you launch, you can just disable it or delete it from the level. You can find that within the Sci-Fi Assets folder under Score and Sound Design. Score is right here, and under Sound Design, you can go to Ambiance and drop in the Ambiance sound. With that being said, I just want to show you a few of the setups for what we're going to be doing for effects. There are some action mappings and some things to be aware of, but I also want to note that we have a Paragon asset we're using for our character. So when you push play, you should see the Paragon character Wraith, the score and the laser effects when we shoot. So you should have this version of Wraith. This is not his native default material. I've added a different material, but you should have this already in the project since it's a free asset pack. We can use that, and you don't have to worry about downloading that. It should just come with the engine. And we will be using under characters and heroes, under Wraith. Here's the blueprint that we will be using for that. And then if we go to our editor preferences, actually our project settings, let's find our input actions. I'm sorry, our action mappings. You should notice that under the action mappings, I have a pulse grenade added, and it's just under the key press G. We have a pulse projectile on the middle mouse, or on the right mouse, a shield on middle mouse, and respawn on R. If any of these are inconvenient or don't work for you, you can always remap them. The action mappings should reflect the correct action mapping here. Doesn't matter what button you decide to choose for it, but when we go into the Wraith player character BP, you should notice that you have action mappings tied to the pulse grenade and the projectile and the shield, and you will see those represented in these colored areas. And you'll also notice under the Wraith blueprint, this is where we're going to store all of our new logic. And you'll see little headers under these comment boxes for what is going to go inside of those. So right now it's all empty, but you will also see here's where we're going to be hooking up our audio components and things like that for some of our sound. So those are the action mappings. Another thing you'll see under collision, here we go. So just come right over here, it's probably a little easier. Just come over to collision, and under engine collision, you will see that I have added a new object channel, and I've called it player effects, and the default response is to block. And basically what this is doing, so if we come down here, you'll see that we have it added in the preset. Once you add it as a new object channel, it goes in the preset, and then you double click on it and you can set all your different collision responses. So you would usually see this, and like if you look at your blueprint and you click on a mesh, you'll go over to the collision settings and you'll see that you can choose block, overlap, ignore, especially if you set up a custom collision. So that's what we're doing in here, but we are adding a collision type. And this is going to be important because not all of these collision types will work for what we are going to try to do, especially when we try to fire our laser beams through the shield mesh. We need a player effects response. And I've set it up to ignore because that's going to be our default, but sometimes we will need to move it back to block depending on what we're using. In production, this isn't something you will necessarily be doing. This is something you could ask an engineer for, or someone else, and most of the time some of these channels will work just fine, just the default channels, because you don't want to add a lot of extra channels depending on what your needs are. But for the prototyping purposes of this course, I've added this just to make it work for what we need. All right, so the only other thing is the folder structure in here altogether. So if you come to just the base level content, we've already gone through where Paragon, the Wraith Paragon character is. We have the Sci-Fi Assets folder. You won't really need to get into this too much. This is just where some of those base, like the spawn platform, the turret, the laser turrets are, your pulse grenade with just its material and textures. Nothing really too exciting, but if you wanted to check out some of those assets and just see how they look in there, we will be coming back to this folder for certain things. And then if you come to this Sci-Fi VFX folder, this is where we're going to be doing all of our VFX. And you will see folders in here. For the most part, they will be empty. You will notice like we have a blueprint already set up for the pulse grenade. We don't want to be doing blueprints over and over again from base level creation. It's just not necessary, but some of them we will. So if I go to like our laser blasts, we have an impact decal blueprint already because there's going to be some logic. But in here in the base level, we are going to create from the ground up our laser beam blueprint and set up all the logic for the collisions and things like that. So don't worry, we will be creating blueprints from scratch, but we will also have some that just are set up because they also hold some sound logic, but for the most part, they're empty. So even if I click on this, all you can see is we have some sound in here, but there is no decal. This is for our impact decal. There's no decal, there's no logic. We will set all of that up ourselves. Make sure that you've downloaded Unreal 5.1 or later, and the reason why is because we're using some new features from Unreal 5.1 that are going to be vital to this course. One of the biggest ones is the character overlay, or just the overlay material effects in general, which we will use on our character for respawn effects and things like that. And that was a new feature within 5.1. So just make sure you have 5.1 or later. Other than that, a lot of the features are pretty standard to what Unreal has been. That's a big one. So just make sure 5.1 or later, and then your engine should work just fine. All right, I'll see you in the next section where we're going to go ahead and start to tackle our respawn effects creation process. See you there. What's up, everybody? In this section of the course, we will be building our respawn effects, which should look a little something like this when we are all finished. In order to accomplish this effect, we'll start by planning for what we need based on our concept. Then, after reviewing our concept, we'll move into our asset creation for our textures, followed by creating the meshes that we need. We will then move into our materials for each part of our effect. I'll cover material parameter collections for global control as well as localized control of assets. We'll use some really useful built-in material functions that will give us greater control over creating masks, animation and timing, as well as some helpful math tips and debugging methods. We'll discuss Unreal 5's new material named reroute node system and utilize material overlays for our character effects, which are new to UE 5.1. Once you've conquered materials, we'll begin blocking out and timing our effects for our energy platform and character particles. I'll also show you some tricks in Niagara for exposing material parameters right in your emitter renderer to give you greater flexibility and control over your materials without having to use dynamic material parameters for everything you want to control through your particle system. Then we'll wrap up with our blueprints. First, we'll create some useful logic in our level blueprint for restarting the level, and also build out some slow-mo functionality by utilizing time dilation to slow everything down. We will then build some logic in our character blueprint to trigger our respawn effects and wrap everything up through our energy platform blueprint, where we will house our animation logic for controlling our character overlay material. We're going to have a blast prototyping our respawn effects for production in this one, and I know you're going to learn a lot along the way. I can't wait to get started, and I'm looking forward to seeing what great creations you're going to make as a result of what you've learned from this part of the course. So let's jump in and let's get started. First thing, let's go ahead and talk a little bit about our concept. So here for our respawn effects, it's pretty basic. We're just going to create some sort of energy. Now, what I don't have represented in this concept is this platform actually lights up. And there will be lights that turn on, but here I'm starting where they have dissipated off and this energy is coming from the outside of the rim, from the light itself, and it is being scrolled into the center, into our character, and as it hits the character is filling with this energy, and you can see these geometric patterns here, and as it fills with this energy, by the time it reaches kind of the climax of the effect, you're going to see these particles transition on. And it's basically going to be kind of this digital particle rasterization of the character. And resemble the character wherever it was left last. So they'll kind of freeze and then they'll fall to the ground as if it has spawned in this character and this is the shell of the character that is being whisked away, kind of in a digital representation, sci-fi representation. So that is the overall concept of what we want to accomplish. And that will kind of give us the language, the visual language, to be able to create our textures, our meshes, all of our assets, even into our animation, our materials, and our particle systems. We have all the information here in this concept to go ahead and start working and begin creating everything we need to accomplish our effects. So before you go to the first video where we start working on our asset creation, I recommend you check out the next video, which is just a time lapse of me creating this concept so you can see a basic workflow of how I operate when I am making concepts, stealing assets from games, trying not to draw everything from the ground up, and just working very, very quickly with maybe some Photoshop paint overs, or any program that you can get away with maybe doing some sort of paint over to represent what you want. I even created, I believe in the concept, some of these polygon textures ahead of time, and I can use them then as also some of the textures that I've created with my concept. So with all of that being said, now that we have our concept in front of us and we have the representation, go ahead and check out that time-lapse video, and then we're going to jump into our asset creation for this chapter. So now that we know what we're going to be creating, let's go ahead and start making our effects. All right, before we get into creating our texture, let's just jump into our concept again and just go over what is needed for our texture creation. So you can see that we have this tiling polygon texture here. And as the energy goes through the character, we're going to push through several different tiling textures. This is kind of an outline that we're left with, but we're also going to create internal polygons in between that outline and also an erosion texture for the polygon. And then when our character is fully spawned in, we're just going to leave an outline with some sprites of the character shape. And it's not really defined for us in this concept, but I'm going to turn these little dots into polygons as well. So we have two textures to make. And again, just to recap, we have our tiling texture and our shape texture. So let's go ahead and jump into Substance Designer and get started on our texture. So if you have downloaded your content, your course content folders, in your VFX folder, you should see a Respawn Effects, and you should see meshes and textures. And we're going to go to the textures folder. Now, I would like for you guys to try and recreate these yourselves. I am going to go through the process of how I made these so that we can spend the most amount of time inside of Unreal and not get bogged down too much in the weeds with all of the nuances and different methods to create textures. I will go through every single node and make sure the workflow is captured, but you will also have the source files so that you can go back just in case you miss anything. But I do recommend creating these for yourselves. When it comes to the meshes though and the simulations, I will be going through how I made those as well, and the meshes I will be doing from the ground up. Usually the meshes are relatively simple, but there are some really cool tips and tricks that I use that will be really helpful, and I'll make sure that I go through that process manually. So first thing is we're going to go in the textures folder, and under the source content, we're going to go to these Wraith spawn patterns here and just open that up if you have Substance Designer. Another thing is too, I understand not everybody will have access to subscriptions and things like that. I'm going to be trying to use industry tools and programs that some of them are a little bit more pricey than others, like Houdini, but I'll also be using an alternative called Embergen. We'll use Blender, which is free, and then Substance is not too bad of a subscription, especially if you want to just buy it for the use of this course. But I also understand not everybody will have access to those things. So I'm giving you the project files as well as the finished textures and simulations so that you can pull those into the project yourself if you're not able to create them. A lot of times in a production as well, depending on your level as a VFX artist, you may already have assets created for you. So the most important thing for us is really diving into Unreal and making sure we understand how to create compositions for effects as well. So this is our texture for the respawn effects. And basically I'm doing multiple things. I love to pack textures into channels. So you will see me use this node a lot, which is the RGBA merge node, and I am just packing different channels so that we can keep everything in one texture and continue to keep texture memory down in the engine and not populate the engine with too many textures. So texture packing is a pretty common technique. You'll also hear it called gray packing and things like that. As you saw in the respawn effects, we have this kind of sci-fi polygon pattern, which will include kind of an outline that we'll be passing in. You'll see here we have these polygons with kind of a border. We will invert the grayscale to kind of create the outline, and then I also have this pattern with a gradient in it to use for erosion. And I'm going to show you kind of how I've used all of these or how I've gotten there. So really simply, I just started off with a polygon node. This is pretty standard. Starts off with 6 sides. So it's just pretty much a polygon node, drop down almost verbatim, but these are my settings for that. Then I usually like to pass things through a transformation node just so I can transform it if I need to. Scale this down just slightly. And you can see I'm using it here. We'll go for the polygon pass first so we don't get too bogged down with the other stuff. But basically I'm just using an edge detect, and I have just made the edge width to kind of give an outline. And then that is going into, for this RGBA node, that's going into the green channel. We're passing the main polygon through to the red channel. And then in the blue channel, we actually have our erosion. And the way I'm doing this is I'm just simply adding a bevel. I chose to smooth it so that these lines weren't as harsh. You can see they get a little bit more pronounced. If you don't smooth it, this just blurs them up a little bit. And then I invert the grayscale again, and the reason why is because I'm going to be mixing I want this to be inside the polygon, and I want it to erode out. So I'm going to blur it a little bit more, just again to get rid of that star pattern just slightly. And then I'm going to send it through this blend, and I'm just going to multiply the polygon. You may be wondering why I didn't pass this through my transform node like this, so that all of it lines up when I go through my RGBA node. You can see that all of the outlines are perfectly aligned. And it's basically because I want the polygon sitting just outside. You can see in the blue area, it's sitting just outside the polygon, so that when I choose to erode it, if I show you through this levels node how the erosion will work, I'm kind of testing it through the levels. you can see it's giving me just a thinner outline around the edge. I don't want it to be too thick, and I want it to kind of erode my outline just a little bit more. So I'm pushing it past the boundary of the polygon just so I can have a little more erosion. And that's why I chose to send it outside the shape a little bit. And then that was just being packed in the blue channel. On the merge nodes, to make sure that if you're using an alpha, or if you're not using an alpha channel, then you want to make sure you just pack it with a uniform color. I just drop down from here, uniform color, and then just send that to white. And now in the output node, so I just again drop down an output, and I always like to name these with an effects prefix. In production, textures and assets can get lost very quickly, especially if everything is labeled T. So I want to make sure that effects are found quickly. So I make sure I label that, and I also determine the version number with an O1, and then you can also create the label down here. Now this doesn't have an alpha channel. It's not necessary to use alpha. It'll be more expensive if you use alpha, so you can just keep it to RGB. So what I did was I just added the item, I choose RGB, diffuse, and then choose my color space. And I set this up on the front end, so when we go to output these, that is already done for us. Now the next part is a little bit trickier because these patterns don't necessarily sit well, perfectly scaled with each other. So I drop down a tile sampler. There's only one pattern input, and I'm basically going 16 across. I've changed that to the pattern input, which is our polygon. Pretty standard stuff here, nothing too crazy. And then we're just going to move into the scale. Now, let's check again. I always like to go back and see what our base parameters are. For our scale, here's the size. And you can see that our size has changed slightly so that we can get this correct. If we were to leave this at 1, show you what happens. It looks like this. And obviously that's not what we want. Now you can try to move things around, but I found that the scale that I'm using works the best, and we can scale it slightly to give ourselves enough of an offset. So let me just get those values back. And now we have a pretty good scale. Now you'll notice, yes, they are a little stretched, but that can be fixed with our tiling. And it honestly is not that bad. You're not really going to notice a whole lot. You can also change this scale if you would like, so that you have, and I would do it by the master scale. So there we go. We can get thinner patterns if we want. You can get a little thicker. You can play with that scale and kind of move through that node. And then I have some offset here, and there's really nothing much else done. But to get the proper scaling, had to cheat it a little bit, and you get that size with a little bit of a scale bump as well. So that's what I'm doing. I think it's pretty similar in these. I wanted to get a little bit, if you notice, I didn't want the outline to be as thick because I actually wanted it to be noticeable in between these. So I wanted the outline to not fill the whole gap because I want the outline to pan through, and you don't see the outline really unless you give it less width or less this thickness than the top. So I did scale these up just slightly so that I had a little bit more of an outline. And then here, this is again just kind of the same thing, same scale, and then we're packing all of those into the RGBA merge. And then again, there's no alpha, so dropping that uniform color down. Otherwise, I would pack an alpha channel if I needed to, but again, we're trying to keep texture space low. I apologize because I believe I did send this out as RGBA. It may read more expensive, but we'll have to check that out in Unreal. I don't think it does. I think it's automatically, because the alpha channel is filled, that it's going to be fine. So, but something to note, we don't need RGBA. it should be RGB, and we'll make sure that we change that. And I'm just going to call that effects Wraith respawn pattern, and this is our respawn hexagon. And then the way we send these out, do it on the graph, right click on the graph and export out as bitmaps, and then you should see that it gives sRGB. One thing, if you're making these from scratch, it will say graph at the front of this. I delete that, and just you can preview what your texture name will look like. So find the folder you want to send it to, preview the texture name, and then make sure it's in the correct color space. And by default, they'll all be checked on. I was sending this out again, so that's why mine is checked off. But you should be good. So just make sure you have the proper naming convention. I'm just using a PNG. I'm using PNGs currently. They are a lot lighter on texture memory outside of the engine, but I'm going to be switching over to Targas in the middle of this course. Targas are definitely a better format, and they give you better alpha information. In this case, we don't have an alpha, so PNG will do just fine with the way we're going to use it, but I do a combination of PNGs and Targas. So in this instance, it's a PNG. Later, it'll be Targas, especially for better alpha information and things like that. Close out of that, and that is our texture creation. Next, we'll go ahead and move into creating our meshes needed for the effects. If we look at our respawn effects again for our concept, we've already talked about the fact that we have this traveling energy going through our player character from the outside of the mesh. So there is already a mesh on this platform, and we want to kind of imitate the same surface as the mesh. So we need a circle mesh, kind of a disk mesh that will have the UVs scrolling from the outside to the inside so we can transfer the energy into our character. So let's go ahead and jump into Blender and get started on the mesh we'll need for that scrolling energy effect. So if you go back to your source folder from your textures, back to meshes and source, I have a file in there you can use, or you can also just pull the mesh in, and I'll show you how to import that shortly. All right, so let's go ahead and jump into creating our mesh. And before we do, I just want to explain this mesh is not going to use the UVs scrolling from the X and the Y direction. I'm going to create a radial UV so I can actually scroll the texture along a radial UV pattern. So I'm just going to generate a band, turn that into a circle mask, so I'm not creating extra masks or anything like that. And that's going to be the easiest way to tackle this, rather than trying to get this disk to go from, an X coordinate that's wrapped like this, and then a Y out like this. So I'm going to start, I will restart this mesh creation. So Shift A to create, if you're not familiar with Blender hotkeys, I'm going to go and create a cylinder. And then 32 is fine. I'm just going to make sure I turn it to nothing for the cap, so I don't want a cap on it, and everything else is good. I can hit 1 on my number pad to get to the front view, tab to go into edit, and then Shift Z to go into this wireframe mode. Now, if you're not sure, Shift Z is the same thing as just clicking this wireframe. So if I do it again, you can see it goes back to the cap, and then that's there. I've used Blender so long, hotkeys are just a thing, and I do not have screen capture keys on, so I apologize. I'm going to grab this by hitting the G key, and then press the Z key to go up in the Z direction, and then I'm going to hold Control to scroll it and kind of click it to each grid pattern, just so I can get the bottom to the origin point here. So you'll see my origin point hasn't moved, and now the origin is right at the base of this mesh. All right, so let's go back to the front view, hitting 1. I'm just drag selecting the top, and I'm gonna scale these in by hitting S and just push my mouse and see how close I can get these, get them relatively close, and then I can just, again, grab G, hit the Z key, hold Control, and just all the way down to the bottom. Now it's flat. So now we have a flat disk. Now I can scale this in a little more if I want. If I want to see less of a hole, it's not really going to matter much. I just want to get this all the way in. You could also, kind of close that off if you want and just merge the points together. It's not a big deal because at the end of the day, this is just going to project anyway. So if I wanted to do that, I could hit M, but before I do, I just want to give it a few more verts, and I should also explain Control R to add a loop cut. And then I'm just using my middle mouse button to scroll up on those and just giving them a few more. Just like to give it a little bit of rigidity. If I end up using this mesh again, I just have some more polygons to work with, but it's not necessarily always necessary. So I'm just going to select these middle ones. I'm going to hit M to merge, and I'm going to just choose at center. Now all of the hotkeys I'm using can be done from these bars, but that is one thing I love about the speed of modeling in Blender is the hotkeys just make everything go so much faster. So hopefully that works for you. All right, so I'm going to hit 7 on the number pad to go to the top view. And then I'm going to go back into edit mode through tab, or you can just come up here and go into edit mode. I'm just going to select everything by hitting A. So that'll select all. And then I'm going to hit U to unwrap. And I'm going to choose the projection. So project from view, but I want bounds. And the reason why I want bounds is if I come up to this UV editing tab, you will see what happens if I just project from view. So U, project from view, and it just puts it in the actual view. So you can see it's kind of off-centered. It's projecting exactly from my view. But if I go project from bounds, it will actually put it in the proper UV space. So just make sure you use that. And now we have our disk mapped just from a projected view, and that is perfect because we're going to, again, scroll through the radial UV function. So the last thing I want to do is I want to create, now if you're doing this from the ground up, you will not have this grid back here. The way that I got that is this should say new if you have nothing. New image. And then I like to call this grid. This doesn't matter. You can select UV grid from here and then hit OK. And then that will give you a UV grid in your UV viewport. Then I go over to materials. There's usually one already named material. I'm just using that. And when I go to that material, you won't see this right away. Let me go back to this. So we're just going back to the matte cap, or to the viewport shading mode. Over here, you'll see that there is an image. So actually, let me just create a new material. This will be a little bit easier to explain. So a new material will show up like this. Then under base color, I can click on this yellow dot and hit image texture. Then from the drop down, my grid will be available because I created that over in the UV viewport. So just hit grid. And this is what I use for testing UVs. So I put this on, we're not going to render it out or anything. It's just for testing our UV pattern. And then it's all set up. So now when I go to the viewport shading, you'll see, and I can delete that material if I want, you'll see that it's there. And I can also just test. So I'm just going into edit mode, and I'm going to hit A over here. And then if I hit S to scale, you can see my UVs are scaling. And that would be if I wanted to, if these were actually properly mapped, I could go grab Y, I could go G, X, and you could test their scaling direction, which we will do later. But that's pretty much it. The only other thing I always do, just so there's a smooth surface, it doesn't matter as much for this because this is a flat surface. So you don't necessarily need to smooth it, but you can just smooth it. And then another thing, just to apply any sort of scaling change, you can hit Control A to apply the rotation and scale. And basically, before I do that, if I hit N on the keyboard, you can see the dimensions and the scale. And this is good, but let's say if I did scale it up, you can see the scale changes. And if I hit Control A and I do rotation and scale, it stays the same in the dimensions because that's its actual physical size, but it will take the scale back to 1. And sometimes that's important for when you're bringing this into Unreal. So then To kick this out, you can just go to File, Export FBX. I just choose the selected object, choose Mesh. Under Geometry, for all meshes, especially when you choose smoothing, to keep them smooth, I choose Face. There's another way to do this where you don't have to choose Face, but usually this works for me. It's kind of the way, if you've ever seen Unreal say, no smoothing groups detected. This is kind of the way of you creating a smoothing group in Unreal. We don't have any animation to bake. Nothing there is important. And we're just going to go up. You can see I've already created the asset here. So SM for static mesh underscore effects again, so that we can find it easily. And then I just called it platform energy base. I'm not going to export it since I already did, but that brings us to the end of creating our energy mesh for the effects. All right, so we are now going to import our assets into the engine, and I'm going to show you a couple different settings that need to be changed and ways that we're going to try and keep our effects assets optimized and properly managed. So let's go to our Respawn Effects folder, and let's go back to where we created our meshes and textures. And we will also go to our Sci-Fi VFX folder. We want to go to our Respawn Effects, and we're going to start with our meshes. So let's go ahead and drop in our mesh. So now notice I didn't put 01 at the end of this mesh. That's fine. We're not going to do any other versions of it, but typically I will always have an 01 even if an 02 doesn't exist, because sometimes you end up creating more just to test, and it's good to differentiate between those. So one thing I always keep checked on is vertex color import to replace. I will use vertex color here and there, and so I just keep it on replace to make sure that it always replaces and it doesn't ignore my vertex colors. There's not really anything on there. We don't really need any other settings. We don't want it to create a new material, and we don't want to import any textures. So we can go ahead and hit import. Nothing else we really need to take care of. You can just right click and hit save, and that should be good for our mesh. Now let's go to our texture, and this is where we're going to have just a couple of settings to change. So go back to our textures, and we're going to pull in both of the textures that we created. And we can select both of those and hit save. And now we should be able to pull up these assets, and I'll drag them over. Now if you're on a window, you can just hit Control Space if you're not used to 5.0's layout, or you can hit Dock and Layout, and this will dock it like Unreal 4 does. But I like to keep it free floating, so I always leave it kind of undocked. Let's go back to our Respawn, Textures, and let's open up this one too. Okay, so you'll notice our resource size is really good. We're just at a 2K texture. There's no alpha channel, otherwise this would be a little bit heavier, but we're good. We want to make sure we set the texture group to effects, because that is where it's going to categorize these textures as effects in the game engine, and there will be scalability, things that need to change based on that. If we did have a texture, let's say we wanted to bring in a 4K texture for scalability purposes in the future, but we don't want it to read 4K on disk, you can just come down here to this maximum texture size and bump it down to a 2K. And if I go, let's say 512, you can see bumps it down to 512, and it'll just limit it to that texture size. Now, I don't want to limit it. 2K is fine. That's kind of where we're landing at this. Because it's a polygon texture and we're going to be using it really small, you could bump it down if you needed to optimize it. But this should be fine for us. So let's save that, and then let's do the same thing here. Just come down here, Effects, and there you go. Now, if you want to, you can actually bulk edit textures, and I'll show you. You can just go to the property matrix here, Asset Actions, bulk edit via property matrix, and this will be really handy if you have a lot of textures that you just need to set the same way. And we'll be doing this a little more. We'll be doing this a little more later. But here we go. You can see you'll get a list of all your textures, and then you can select and you can choose different properties based on the texture itself, or if you want to bulk edit, you can just select both of them. You can come over to the display and edit over here. So you can see we get some of our options. If you want something that looks a little closer to what you're used to when you open up a texture, just go to the property editor and you'll see we get all of our options over here. Now it won't be laid out the same way. So you can see like our maximum texture size is all the way down. And then we have our texture group is all the way down here. But if we do set this back to world, you can see it sets it back to world. And let's go back to effects. And then if you wanted to change compression or anything about all of these to keep them synced up with multiple textures, you can, and you'll see that they're not saved. And you can just come down to your unsaved if you want. You can see what's not saved, and then I can just choose to save my textures. And there you go. And so that's an easy way just to keep everything organized, especially if you have a lot of textures you're trying to bring in all at once. Bulk edit is great, and we'll be doing that a little bit later too. And I know I would open all of these textures individually for a long time, do the effects, and had no idea about the property matrix. So just a really handy tip. Anyway, I will see you in the next section, and we will be going through creating the materials we need for respawn effects. I'll see you over there. First, before we even start creating material, the one thing that I want to do to kind of create a global color parameter to change for each effect is I want to create a material parameter collection. And this doesn't necessarily mean this will always be the case, because there will be times where you don't want to do this for production purposes, but a lot of times for prototyping, I will do this so that it's easier for me to show my art director and he can kind of look over and say, hey, can you change the color to this? Well, sure. And I create a global color parameter so I can change all the effects to a different color rather than going in and changing colors one by one or changing the color for a particle system, things like that. This just makes it really easy. And sometimes this is appropriate to create a material parameter collection to have a global color scheme per each effect. So the first thing I'm going to do is come over to our global folder. So I'm in the Sci-Fi VFX folder, go into global, and I'm going to go to materials and create a material parameter collection. So we're just going to label this MPC, oops, no space, effects, and I'm just going to call it master parameters. Now you could give it a more specific name if you want, but this is going to be our master, and honestly, I guess we could call it master color parameters if you want. Master color. We don't need the parameters really. Master effects color. Okay, so you'll see right away, if you're not as familiar with these, you have scalar parameters and vector parameters. We're only going to use the vector parameters for this MPC. Because that's going to give us our color. And I'm going to call this respawn color. Now we'll add more of these. So right now we have respawn, but we'll be doing them for all of our effects to have kind of a master list of colors that we want to use. So I'm going to go for kind of a blue somewhere in here. And it doesn't really matter, but I'm just going to give the alpha a 1 so I have a solid color to look at. And there we go. This is something I should probably also mention. This may be in your project where you actually have the palette open. Forgive me if I insult your intelligence here, but just a trick in case you didn't know this is you can just pull whatever color you've chosen, pull it up here, and then you can also rename it. So you can have multiple palettes. So if you want to rename this palette and make it, you know, like effects colors, you can. And now you have an effects colors palette. Then you could do a new one and you can have multiple palettes. Sometimes these go away. There was a bug in Unreal at one point where these would actually just delete out randomly and I would lose all my effects colors. So not necessarily the best to store palettes in here if you're trying to reuse them. I will just keep them in a material parameter collection, even if this isn't tied to anything. But it's very, very handy. And if you wanted to take it out, you can just drag it over to the trash and take out that color. It may be tempting for you to boost the emissive intensity by changing the value and going to like 500 or something above 1, but I wouldn't do that here. We're going to use an emissive value within the material shader itself to get our emissive intensity. So we're just going to choose base colors, so everything will just be a good color set within a 1 value range. And we're going to use these in our materials. So that's why I'm setting it up right now, and that's why it's under global, because this will be for all of our effects. So let's get in our respawn effects and go to materials, and we will create a new material. This will be m_effects_energy platform. And I also like to give it a base tag at the end. It's not necessary, but it just helps me know that's the master. And master is just a few more letters. So base works just fine as long as you have a consistent naming scheme. We're going to open that up. And the goal for our color, we don't need translucent. It's really just a scrolling color over the top of this platform. So let's just give it a additive shader, and let's make it unlit because we don't need the lit information. And then we will start going about creating our material. Now, if I was using this on a second screen, I would pull this over to second screen, and I would go back to my map and pull in my mesh. Not if I was using a second screen, but if I was using a second screen, obviously I would have this over there, and I would be looking at my mesh the whole time I'm making these materials, so that I can go ahead and just see how it's working. So I'm going to drag this onto the mesh, and this material will update eventually, but I want to make sure I give you the most real estate so you can see what I'm doing first. So the first thing I want to do is I want to pull in my texture. So again, control space. I'm going to drop that in. And a lot of times I like to just go ahead and turn these into texture objects and pass them into a texture sample node. But we're going to keep this one simple. And so I'm still going to make it a parameter. And I'm just going to literally call this spawn pattern. You can give it whatever name you want, whatever makes sense. And because this is a tiling texture, we're going to go ahead and just affect the scale. So we can change the scale as we so desire. So let me go ahead and just drop down a UV coordinate. I was just holding U and just pressed, and you would drop down a UV coordinate. Again, I am very much a hotkey guy, so I apologize if I'm not going to search through here. But again, you can just right click and search, or you can drag off of something and then search. You already know that probably. Regardless, I will still talk about hotkeys when I use them because I know it's frustrating when things appear and nobody knows, kind of what's going on. So held M for the multiply, drop this in here. I want to multiply the scale by this UV coordinate, and I want to have control over X and Y in case I want to stretch this pattern slightly more. So I'm just going to append my vectors so that I can have an X and Y. Hold S for a scalar parameter, and I'm just going to call this tile X. And we can give that a value of, I think I'm going to go 2. And then do tile Y. Usually I'll start with 1, but I want this a little bit smaller. So go 2, and we'll just pass it into the UV information. There we go. And I'm going to put a comment box around this to keep everything organized, and I'm just going to call this texture. Just texture. And what I like to do, especially for materials and material instances, I like to group things, and we can just call this our spawn pattern. We can put that in there. And then if I had multiple textures, I'd create a group for textures, but I just have the one. So I'm going to also group that in spawn pattern, but I usually keep this in a textures group. So that will kind of organize our parameters once we get down to it. So the next thing I want to do is I want to build out kind of a banding mask. Now, first thing, let's just plug this in and see how this is looking. Now you can see if we do the full color, obviously, it's going to give us that RGB value. But here's just a test for what that looks like, and then we can also do the opacity so you can see through it. And if we update this material, see we have a nice little pattern on our disk, and it was projected because of our projected view, so it's just kind of on there nicely. There we go. Depending on how you look at it, it kind of looks stretched, but it's actually good. All right, so let's go ahead and get our mask. And this mask is what we're going to use to create that circle pattern that you saw in the original video. And I'm going to do that through a band. So I'm going to choose a generate band. And I always like doing a width. And we'll call this band width. I also like to read my parameters a little easier. You'll see a lot of people smushing these together. I know programmers hate seeing when I do this with spaces, but I always like to read my parameters a little faster. So to me, as an artist, this makes more sense. All right, so band sharpness, we'll pass that in. I'm going to start with a width of 0.1 and see where that gets me, and then I'll start. Actually, we won't make this sharp at all. I'll give it a little bit of a fall off. And we can kind of see what this is doing. We'll drop down a multiply node, and you can kind of see if we start, see, if I hold control, by the way, if you hold control and zoom in, you can go a lot farther. But I'm going to zoom in. I can also just preview this and see what my band is kind of doing and what it looks like. So this is good enough for our purposes. If you wanted more fall off, you might want to actually do a custom texture and control that. But for now, this is about as sharp as I want to go. I don't think, let's see, how far can you go? Yeah, negative values actually work really well. So there you go. You can do some negative values if you want to get more of a fall off and kind of keep it through there. So let's just go back to 0. It's going to work for what we want. Now, the great thing about a generated band is it has the UV coordinates, so we can go ahead and give it a vector, a radial vector. And this is the vector to radial value. And if we go ahead and just plug that in, it should give us, yeah, a perfect circle. Now, again, I want to make sure that my coordinates have some sort of scaling to them. I'm going to use that to shift. So I think if I were to offset this, let me try a offset real quick. And then there's also the compare. If we offset this, we can do kind of something like that. You can see it kind of animates in and out. But I don't get any tighter patterns than that. And in some cases, I want more bands in between here. And in order to affect that, you need to affect the UV coordinates. And so I'm actually going to do the offset, but also multiply kind of the scale through the UV coordinates. So to set that up, we want to multiply let's do a scalar parameter, and we're going to call this band tile. Because we're technically adding more tiling. Now I'm not doing the vector because I just want to affect this in a uniform way. So I don't need X and Y, I just want one master value. And you can see 0. If I go to 2, you can see I now have more bands. And so that will allow it to read kind of more along the way that I want it to read. And it gives me more control over how many bands that I get. Now, shifting our UVs is usually done through kind of adding to the UV coordinates. So I want to add And I'm going to want to add the Y. So I'm going to add that, but I'm also going to, I'm not going to add, sorry. Let's just take our append from up here, Control D, and we're going to add to our coordinates, and I'm going to add in the Y direction. Don't need anything, don't even need a parameter for the X. I know I want to use the Y, and I'm going to then create one called Shift Y. We'll eventually turn this into a dynamic parameter because we're going to use this through a particle system later on. But for right now, this will give us a good test. Now here's where the testing comes in. I want to make sure this is working. I don't always get complete real-time feedback. Even though this says real-time and all that, it will just skip to see as I'm sliding it. It's not really showing me. I can see that it moved. So I'm going to pull this out. I'm going to go back and I'm going to save this material. And I'm going to use this in our opacity. There we go. And now I can see it's scaling the way that I want it to scale. And if I wanted to add more width, obviously I can add more width. If I wanted to add more bands, I can add more bands, but greater flexibility through that UV channel. All right, so it's working. And now we want to go a little bit further. Let me stop previewing this node. See what it's actually doing. So now we want to use this as a mask for our texture pattern. So I'm just going to take this multiply and we're going to pull off the red because that's the pattern I want to see. See these nice polygons creeping through. You can see it's working. So I'm multiplying that by the mask. And then I'm going to add a radial mask because as you can see, it goes all the way to these edges and I don't like that. It's definitely going to look like it's cut off. And so I'm just going to create a radial gradient exponential. I'm going to create a parameter from here, call it mask width. You could also call it radius. And we're just going to give it a 0.5. Again, I like to just drop down and multiply, and you can see what it's doing. Let's see the width. So this is cutting it off so it's not going all the way to the edge. So now we have more of a circular pattern, and this is going to look really nice, especially since we're going to keep this from going around the edges. So we're going to drop the mesh directly over the top of this and keep it from going off the edge. So then we're going to just create another parameter for density, and I'm just going to call this radial mask density, and I'm going to also label this radial just so I know which mask. One's a band, one's radial, and I'm just going to give this a value of 1. You can see that density gives me a little bit of fall off around the edge, and then we're just going to take the results of our multiply and we're going to multiply it there. And now you can see if I were to plug this in, and you can see there's a nice fall off. Now this looks super light, and that is okay for right now because we're going to be boosting these color values, and it's going to have some nice fade and fall off later on. So right now that's not a problem. And now we're going to create our color and our final parameters for using this within a particle system. So first of all, let's comment box this. It's our band mask. And I like to put comment boxes so people can see things and also just keep it organized. And then we have our radial mask. Now, one thing we didn't do real quick is I'm going to create groups for these. Band mask. Would be easier to do it on one and then you just duplicate. Don't need that. Okay. Radial mask. Okay. All right, and now let's create our color. Now what we're going to do here is we need to get our color from that MPC that we created. So let's go into our global folder. Let's drag that in and let's choose respawn color. Should see that come up. And now we're going to multiply that by our result from our mask. Let's drop down a multiply. Okay. And then let's drop down another multiply. And I'm going to also create an emissive, whoops. That's not how you do it. Hold S, scalar parameter, emissive intensity. And I'm going to define the emissive intensity. It's not going to get more emissive in any way. I'm just going to define it in this parameter. And we will call this our color group. This will go into our emissive. We already have our mask. And now you can see we've got some really cool bands going here. The last thing I want to do is I want the opacity to change per the particle system. So I'm going to also multiply a particle color and multiply in the alpha channel. We'll go into the opacity, and there we go. Have that. Let's do color. And now we have our texture for our platform. Now let's save this. And there we go. You can see we get a nice scrolling pattern for our texture. We already know it scrolls, so that's good. The last thing I'm going to do is I'm going to replace this shift Y with a dynamic parameter because I want to actually animate this in the particle system. And I'm just going to call this animate energy. In the red parameter, we can keep it at 1, that's fine, and we're just going to replace that Y. Sometimes I like to keep this here just to show what a value is. So if a value is anything other than 1, it was very specific, I'll keep this around, but we can just delete that because we don't need it anymore. We're going to be going through that dynamic parameter. One thing I like to do as well, since this is going to be a particle system, we'll go through kind of what it looks like, but I like to just kind of get it to a placement on the object that we're going to be using it for. One way we can do this easier is to select the spawn platform and just check the location, and I'm going to copy that value, and here's our mesh. I can right click and paste that value, and then I'm just going to, that way it's right on the origin point, but I can bring it right up on top of the mesh, and it's a little low, so let's bring it up, and then we can scale it the way that we want to, so we know it's going to scale there. And then I could test that energy shift. So let's do that. I know I said we get rid of that shift Y, but just for testing purposes, I won't even rename it. Let's just do this and see how it's moving. So there you go. It's moving out, and you can see it comes a little bit out from that outer edge. If we wanted it to come out more, I mean, we could always scale this up to where it meets. And now we know the actual scale. So when we put this in our particle system, we can use these scale values to test kind of how far we want this to go. So that's a good way to test it. And that is the end of this material. All right, I'll see you in the next section. All right, we're moving on to our overlay material. Now, if you don't know much about overlay materials, this was something introduced in 5.1. And if I can go to my character real quick, I will quickly show you. So let's just drag in Wraith here. Okay, and if we go into the blueprint, because that's where we're going to be dropping this overlay material. If we go into the blueprint, we can see under the mesh, if we search for overlay, you can see there's an overlay material. Now, the amazing thing about overlay materials is it allows you to put an overlay material on the top of any mesh instead of actually having to go into the material for that mesh and navigating through any complex material structures and trying to put in all that logic. This just allows it to go as a skinned material, and we can change it on the fly. We can also add it in via Blueprint. We can set it via Blueprint. We get a lot of control, and it's just really easy. It makes character effects, prop effects, weapon effects a lot easier when you don't have to manipulate an actual material, especially if there's a specific workflow that your studio is going through. So these really are a godsend for us as VFX artists. And I'm going to show you kind of how to navigate creating a overlay material like we had for our character. So I'm going to, first of all, just keep our mesh. Let's get the actual skeletal mesh for Wraith. The skeletal mesh doesn't necessarily have the correct, this is what it ships with, and this is the one that I'm using. So we're going to keep both out here. That way we can test it on both, but at least with this I can see if it's working. Let's go back to our content. Go to our effects, our respawn effects, and then we're going to do our overlay material. Wraith respawn overlay. Again, this is the base. All right. So for this one, I'm going to use a translucent material. It can be unlit. Okay, as far as I know, overlay materials have to be translucent. I don't think we can use an additive material here. So we are just going to stick with translucent. That was what was recommended. And the first thing I'm going to do, again, let's pull this up here. Pull this over. Let's drop in our texture. So we want this spawn pattern again. And again, we can call this parameter spawn pattern. And this time we're going to affect it uniformly. I don't need any special scaling, at least not right now. If I decide I do, we can manipulate this later. But I'm just going to let's call this pattern scale so we have more of a specific name for it. Again, let's give the group a name, and same for this, that, and there we go. Now we should see that we have our spawn pattern. And we're going to be using multiple channels for this. It's not just going to be the red channel. I also need to give it the correct scale. There we go. All right, so you can see that's working. So the first thing I want to do is I want to actually get this working within the character itself. So if I save this, let's just go ahead and find the overlay material. Let's go see if it will work. Yep, overlay. And we can just put this on the character. There we go. So that's what it's looking like currently. Actually skins pretty well. There we go, and kind of forces itself all around every part of whatever is attached to this mesh, which is really, really cool and really handy. All right, so that is skinned on there. Now I want to be able to transfer the energy. So this was the goal when we watched the effect. And maybe we can watch the effect again. Let me bring over my other engine. Okay, so if I were to respawn in NZ, you can see the engine or the energy goes up through the character. And then there's a trail, like the outline also scrolls through those polygon patterns. Let's do one more time. So it transfers up, it transfers into the mesh, and then scrolls up. So to be able to do that, I need to be able to affect the height of this and create some masks to work on that. So let's come back over here. Let's get over to our mesh. And then let's go ahead and start working on how to affect the height. So let's go here. I'm going to use absolute world position. Now, caveat, this, if it doesn't go high enough and your character jumps, then he could clip out of the top of the texture if the texture is not high enough. But because we're using this for respawn and it's going to happen fast, this is going to be okay. And you'll see what I mean. Absolutely. World position. See, I'm talking and trying to type at the same time. You'll see what happens, and because again this is a spawn effect, as soon as he spawns in, it's not going to stay on him, so it doesn't matter as long as our height is good. So I want to take the absolute world position, and we're going to create a component mask, and just take the blue channel, because we are going to be going in the Z direction here, and I'm going to divide this. And then I want this to step by half. And I'll show you why this is happening in a moment. Well, I'm going to go ahead and promote a parameter from here. And I'm just going to call this respawn fill. And this is how we're going to basically fill the character with the texture. Let's just start with the value of 1. Okay, so now I'm going to multiply this by our red channel, because that's what we want to go through. And then I'm going to basically send this into the opacity. And ultimately, this should also go through the emissive color. Okay, so what's going on here? Let's take another look. So right now we have it going into our opacity. We're affecting the opacity of this material. So we have our absolute world position, which is obviously a vector coordinate. So we're just taking the Z value through the blue channel here, and then we're dividing it by a number so we can control the value of that Z value. And then we're taking it into a step, which is just fitting it kind of into a 0 to 1 range, and we're cutting it in half so that we can kind of kill the opacity on half of it, and then below will be a 1 value. So basically 0 on top, 1 below is kind of why that's in between at a 0.5. And we can kind of visualize this through some debug values. So let me pull this over here. You can see I've saved it. Oops, let me save that again there. You can kind of see how that's clipping. All right. So I'm going to visualize this a different way. I like to use debug values a lot. And the first thing we're going to do is debug our float3, which is basically just our vector. Vector's 3 floats. So we're going to see kind of what the vector values are doing, and then we're also going to see what our scalar values are towards the end of this here. So let's go to our debug scalar. We can preview these just by adding a multiply node, expanding it, and then plugging that in. So we can see kind of it goes to 0, even though we're at a value of 250. Let's plug it in here and see if there's a vector value that it's demonstrating. If I hold control, I can zoom in further. Okay, nothing. Okay, cool. So let's take our vector value, and we should be able to see, if we start previewing that node, just turn it into a square here. You can see there's actual values. And better way to visualize this, let me go ahead and drag a plane. We'll keep it on the Z, I'm not going to rotate it. and we will drop an overlay material on this. Let me save this again, and you should see, whoops, let me hook this up. Let's go into the emissive color and let's drop down a constant and just give it full opacity, and this will allow us to visualize it on the plane. All right, so we're going to see it on the plane. You can see that there's values because now we're actually visualizing. This is not visualizing the world position of whatever object we have, so now we can visualize an object in world position. You can see it's just being affected on the z-axis here because we've masked it out. So we have our z value being affected. And if now we were to send this into our vector value through the divide and the respawn fill, you should see this value change. There we go. So now we're dividing it. Now we have a lot lower number to affect. If I start playing with these values, you'll see how we're kind of affecting these, which really won't do much for us. This is basically going to increase the opacity or decrease the opacity. You can see if I go to 150, we're at like -1 on the opacity. Negative, is that even a, yeah, negative point, or sorry, just 0.164. And I can keep going negative, and you can see we're just kind of going up into those values. So it goes to the 4s. If I'm raising it too high, there's just some weird things going on there. So we know we can affect the values, but now we need to fit them into a 0 to 1 range so we have consistency. And that's where, if we start doing that with our step, see, now it's at 0 when we're at 0, and that's fine. And then you'll see that it's going to 1 here. Now we actually probably need to swap this over to our scalar value. So let's do that. Let's go over to our scalar value, and now you should see this swapping. All right, so not really much is changing until we get to a certain value. This should dip. Let's see how far above we bring the ground plane here. So 500 is a good value. See, there you go. So at 500, we're at full 1. 250, we still have 1. 350, back down to 0, we're at 0. Let's try 5, nope. 50, 150, 850. Okay. 850 was pretty dramatic, so let's go back down to like 200. Okay, 250, yeah, 250. And then you can see, let's say we go down to 100 again. If we bring this down, and let me see if I can go below, because that's actually sitting up. There you go. So in world position, once we get to a place where the value is at 100 units, we're getting to a full 1. And that is why, see, through our divide, we can control the way that this is scrubbing up through the character. And then by using the absolute world position, we can actually control the opacity from 1. So we're able to kind of cut it pretty harshly in the center, kind of bisect that 0 to 1 value through the step node, and then raise it up until we get that 1 value. And we need to change it again. Oops. 50, 300, we're above. Yeah, there we go. So now if we just plug that back in, let's just affect the opacity again, this again. You can see how this is affecting the character. There you go. And now we can obviously move this up through the Z direction, but it's going to completely envelop the character that one. So you can see here's our, we're cutting it in half, so that's the 0.5 in the step value. And then here's our 1, here's our 0, and we're just eroding through that 0 basically. So anytime we go to a value where we're reaching this number, we go through this value or reaching this number, we have a 1, and there's a 0 up above, and we're just sending it through until we get a 1. So it's a 0 to 1 hard cutoff basically. Let's go ahead and just send it to the top so we can see what it's doing. Basically, I don't want it to be this pronounced. I want it to be kind of a subtle effect. And so I'm going to use a Fresnel to mask this off. So let's do that. Let's add a Fresnel mask. Basically, we'll just add Fresnel. And then I'm going to just create a parameter here. I'm going to call this Fresnel amount. And I'm going to give it about a 1.5. So it's not super heavy. Okay, now we need to multiply the Fresnel by our mask because we're basically, so I just use this as emissive color. And of course, opacity. So we just get the Fresnel on the character. Let's also just introduce a quick color. So from our color parameters we did earlier, you can multiply that color. There you go. Let's see what that looks like on the character. There we go. Nice little Fresnel. So we're going to use that to mask out our values here. We're also going to mask, the opacity. So that should blend. Yeah, there we go. Now we have a nice, cool looking Fresnel going through our character with those patterns, and it's not super opaque, you know, kind of all over the character. It's nice and subtle. All right, so that's looking good. So we have our texture pattern. We have our height, and we have kind of our color, which we will actually use color in just a moment. Okay, so I want to send up the outline pattern through the polygon pattern, but I don't want them to go at the same time, so I just need to offset the timing of that just a little bit. So we're going to use the same setup that we've already used. We're just going to duplicate it, and we're going to divide by a number to offset the time. So let's go ahead and set that up. And so I'm basically going to divide one more time, and the division will be determined by a parameter. So I'm going to take whatever this value is from our respawn fill, and I'm going to divide it. Now initially I'm just, by 2 is a pretty good estimate because it's going to send up the pattern first, and then it should send up the grid outline next. So let's just call this I'm going to call it height fill spacing. So this is how we're going to fill our height, and we're going to choose how far apart in time we want it to go. Okay, so in order to get kind of that outline going up through the character, we're going to need to keep this base pattern in the Fresnel, but we're going to now need to transfer kind of the base layer to that outline. So what that means is I want to make sure that this red channel is going through our Fresnel so that that's masked out. And then I also need to multiply the Fresnel pattern. Before I do that though, I want to basically take this multiply and redirect it up here. And I need to now add, I need to multiply the Fresnel by this green channel, which is our outline pattern, as you can see, because that's what I want to come up next. And then the same thing, I had to multiply the first respawn fill by that red channel in order to get it up. I'm going to do the same thing to scroll it vertically. I'm going to multiply it by green channel. So now this should go in the vertical direction. Now, in order to bring these together, I'm going to add the new pattern over the top of our base pattern. So I'm just going to put that there, and I'm going to add to the base pattern by using this add node. And now I'm going to send this into our opacity. So let's see what happens. And we need to make sure that we add these together again for the color. So let's do the same thing. So here's the add for opacity, here's the add for emissive color. And let's see if this works. Let's get rid of that multiply. Right now it's a little spaghetti. We'll clean that up in just a moment. Let's see how that's looking. All right, so we can't see it yet. Because remember, we're dividing by 2, so technically this is probably further down. Let's see if this works. Respawn fill. Okay, yep, there we go. It's really hard to see, so it didn't look like anything was happening, but it is there. So let's see where that actually starts to happen. Let's see if it goes down, all the way lower again. Should go down first. Yep, there we go. You can see it building through those polygons. Okay. Now it should be at 300. We should see it gone around 300, 374. Okay, because that's because we're not doing the full 2. If we were dividing by 2, you should see. It's about the same. I think that's also playing into the step size. Okay, so there you go. Now, if we wanted to change the spacing, we could decrease the division value by like 1.5. And we should see that it starts to go up. I don't even think we're fully built yet. Yeah, so it starts to go up a little earlier before this is even fully transferred to the top of the character. There we go, and then the fill can kind of, again, it's very faint. This will be a lot more apparent once. It'll be a lot more apparent once we get the emissive color in there. But you can see that we've got our outline, it's looking good. And now we have both of those together. Okay, so the next thing we want to do is introduce some erosion to this. I need not only it to go all the way up to the character, but it's also got to erode from the bottom to the top. As you saw in our example, it also travels all the way through the character as if this energy's been transferred in and then sent all the way through the top of his head. So we need to build that. So first of all, let's just call this our height fill. This is our texture again. Okay. And then we have our Fresnel mask, so we can keep this together. And we'll eventually build out our color, which actually, before we do anything else, let's go ahead and build our color. And we will start by just stealing our MPC value again. So let's go back to our content and our global, and let's drop this in. And again, we're going to use our respawn color and get rid of this color node. Here we go. And first things first, we need this add to send into a multiply. So we can multiply our color and actually get some color. And then I want emissive intensity again. So let's multiply. And let me just bring this back here. We don't need to see the guy while we do this. It's pretty basic. All right, emissive intensity. There we go. And let's just set it to 25, kind of like we had for our spawn. And I'm going to send this into our emissive color. Let's see what's happening. Okay. So you can see we have that kind of blue there. Now I want this outline to pop a little bit more, and it's not going to pop out as well with the same emissive value as the base pattern. So I want to kind of give it its own ability to change. So before we add it to the color, we're going to send it through a multiply. I'm going to call this boost second pattern. So let's create a scalar boost second pattern. There we go. And so, like I was saying, before we add it, you can hold Control and drag, and let's pull it here. So now we have that. Let me pull this out a little bit more. And let's give it a value of 50. Now you can see in this pattern, we really get it to pop out. And it's going to stand alone. And we can change that later. But for now, we have a very popped out kind of pattern for the lines. So there you go. There's some intensity right there. All right, we're going to keep that there. That's going to be our color. And we'll revisit that to change anything we may need. We'll just go ahead and organize this a little bit better. All right, sorry, my OCD is coming out. All right, here we go. Now let's work on kind of that height erosion aspect of things. And this is just simply going to be us passing in another absolute value or absolute world position to basically reverse the traversal of this texture, bring it up from the bottom instead of bringing it through to the top. So we're going to create our height erode again. We can basically just steal, actually we can steal all of this. So we want it to operate in the same way. And I'm going to steal a parameter that we're going to call respawn height erode, for lack of a better term. You know what? Since we called it fill, let's call it empty. There we go. We're going to empty it. Now, this is going to do the exact same thing we have in the other one. So we need to basically reverse it. And we can just use a 1 minus, and this is going to reverse the mask. Instead of filling it up, it's going to empty it up, if that makes sense. And we can just multiply that by our opacity. And you should see this work once I take it up. It's probably going to be around the same value. Let's go back here. Okay, so if you look, now we should see this once it gets around that 180, 200 frame. Yep, starts to take it up. There you go. So now we're emptying our fill from the bottom. Awesome. That's awesome. And let's make sure it's around 150. I think we can start there, and that should be good. Now here's the thing. This is what I was talking about before. If I bring this character up, you'll see he starts to defill. So if you were to jump up, this would, if you have a character running around, he's got to go up stuff, this approach would not work. There are other methods to do this, but again, this is the method we're using because he's going to be in one position. And honestly, I think the reason why, let's see, let's bring him onto the platform. We'll get a better reading as to what the height needs to be, because we're already moving him up because he'll be starting on the platform. So we need to know what that height value is going to be. All right, so that is our height empty. So we have our fill, we have our empty. Next, we will tackle the last part of the material, which is our erosion and distortion. This video is going a little bit long due to the nature of this material, so I'm going to go ahead and split this into 2 parts. And so let's go ahead and jump over to the next section. And now I'm going to do an erosion, which is going to be that part of the texture we set to erode, which is this guy, if you remember. You can see those patterns in there. So those are the inside of our polygons that are going to kind of push out and erode. First thing that I use for erosion a lot is a smooth step. Again, that's returning kind of a 0 to 1 value so that we can automatically kind of clamp it. And it's also going to give us various values to where we can make part of the erosion softer so it's not just a hard cut. So typical workflow, I take value. This would be the erosion amount, and then this would be the erosion softness. And the erosion amount goes into the minimum, and then it is going to be added to the softness for the maximum. And this basically is from 0 to 1, so as soon as it goes to 1, it should fully erode out, and if it's at 0, it will be in. And then the softness just gives it kind of a little bit of a buffer value to soften that erosion, so it's not just a hard clipping value. And then for the value itself, we're going to pass in the blue channel, and we will multiply that by our opacity. Go. And so now we have our erosion, and you'll see how this is working. There was a better way. I know I don't have 2 monitors, so I apologize that I keep just bringing this out. But here we go. So should be able to see this erode. And I may not have saved this. Let me try this. There we go. Forgot to save it. Yeah, so there you go. You can see it kind of eroding, and it's eroding the line too. So it's kind of popping out. And we're going to use that to kind of just transfer this, kind of give it a cool effect and kind of a blend. And here's what the softness will do. You'll see me use this a lot. That softness value, just see how softer it is. Whereas if I go 0, you can see there's a very hard edge erosion. And I like to keep it around 2.5 or 0.25 just for some softness. Now we're kind of getting a really cool balance on this character. And that's looking really good. All we need to do is add in some values to now animate this. And we're not going to animate this through a particle system. This is going to be driven through a timeline in a blueprint. And so we want to bring all of these values together and kind of animate them at the same time. So we're going to use another material parameter collection. And the reason why I'm going to do that for this is we're going to be using the spawn platform blueprint as our base for animating the material. Well, the thing is, this material does not exist in the spawn platform blueprint, and I don't want to have to call the character blueprint and do all this extra stuff. So the easiest way is to use a material parameter collection because it'll affect whatever parameters are, and we can call the material parameter collection in any blueprint, but it will affect any parameters attached to it, but we're only going to use it on the character. So let's create another material parameter collection, and let's go to our respawn, our materials, and we'll create that guy. All right, NPC underscore effects, and this is character. We'll call this Wraith Respawn. Now, we know we want to fill. We want to use our fill parameter. We don't necessarily need to use the same names. I'm going to replace everything. So we have our respawn fill, and we have our erosion amount. And we're going to replace that. And we're also going to use our height empty. And I may tie something else into this for the platform, but at the time being, let's go ahead and add those. So we need 3 different variables or parameters. And we're going to do our respawn fill, our respawn empty, and our erosion amount. Okay. Now nothing's really going to stay anywhere because we'll define the values in a blueprint, but we're using this as a holder for the values, again, that we'll call somewhere else in the platform. All right, so let's go back to our material and control space. Let's go respawn, materials, NPC, and let's start swapping. So I'm going to keep, remember I said earlier that sometimes I'll leave values around just so I know what they were. I'm going to do that here. So I'm absolutely sure I'll just keep the values there. So we know this was our respawn fill. I'm going to change the name. Respawn fill. This makes more sense. And respawn empty. Same thing here. I don't know why I'm changing the name of that. I'm replacing it with this. Okay. And make sure we change this to empty. Keep that there. And then our erosion amount. We also need. And I don't need that. This one I don't need to keep around. I know it's 0 to 1. That's pretty basic. And we will just change this to erosion amount. Okay, this looks really good. We're going to save that. Again, we've already got it tested. We don't need this guy anymore. We will delete him. Delete him out of our level. I can, where did he go? Okay, I can delete that guy. There we go. All right, I don't know why that wasn't working. Okay, so let's just save our level, save all, make sure we're good. We already know that this works. Let's delete that too. All right, the last thing I'm going to add is a little bit of distortion, and here's why. I want to show you when he spawns in. You can see when it comes up, it stretches a little bit. It's hard to see, but it stretches a little bit at the edges. Now, it's not as noticeable, but if I go ahead and do this, you will really notice it. So I'm going to set the distortion to 0, and you'll see why this is important in a second. Very hard edge, if you saw that. There's a big difference there with the hard edge and how it just kind of scrolls over the character. So I like adding distortion to a lot of things. We're going to be doing it quite a bit. But here is how we add it to our material. So we're going to come back to our base material, and basically we want to add it anywhere we have our UVs, except for our actual texture, because all we want to affect is the line at the bottom and the top of our fill and our empty. That's all we want. So it's going to affect these two things. We're going to basically take our spawn pattern and let me see if I can get my spawn pattern back. So we could turn it into a texture object parameter instead and send it through a texture sampler. So hold down T, you can send it in there. I'm going to just kill this texture so there's nothing in there. And we can do this, hold control, just take these pins. There we go. There's nothing there right now. This is what we'll call our spawn pattern. Okay. Throw it in our texture. And then we will do the exact same thing. This spawn pattern can stay. It's going to be the exact same parameter. So just passing it into this. So let's do a component mask. I'm going to be using this to add some distortion, and I'm going to take the blue channel, which is already has some blended values. It's not just a straight 0 to 1. There's some good grayscale values in there. So I'm going to take the blue channel and also take the R and the G, because I want to turn this into a RG value based map, because that's what's going to distort our UVs, because our UVs are RNG from 0 to 1, basically. So I'm going to use this to kind of distort everything. I want a distortion amount, and so I need to multiply it by both of these. I could just take the blue channel and make an RNG, but I'm doing them independently because it gives me a little better result than if I were to try, let's see. Let me see. All right, so we can see that the RG goes in there, but if I were to say add a scalar, distortion amount, I want to boost this to something high. I'll boost it and I'll show you why I'm keeping these separate. So we're just going to do this through the named reroute. So add reroute named reroute. Call this distortion. Keep it blue. This one. Okay. Now I've got to plug this in to the 3 areas I showed you before. This is going to go after. We've already defined what the value is. And we're going to add it to the top. Let me just control drag, it'll be easier. Let me pull down this a little bit more and give us some space. Okay, our named reroute's distortion. Plug that in. Same thing. Control D. Let's pull all this down. Grab and pull there. There we go. And then let's do the same thing over here. Oops. Forgot when you control D, if it's whatever the last node was. You have to control C if you want to truly copy and paste. All right, there we go. Distortion. And now we should see that difference. Let's see what it does right now. So remember, we already used our MPC values. Let's crank up the fill. We know that needs to go to around 800. And then let's kick up our empty. And let's see where that is going. Oh, somehow my map, okay. So you can see not much is happening in the way of the distortion, even though it's been cranked up. So let's go back and do the separated channels. Again, this just happens to work really well. Let's add them together. So they're distorted separately. Or the values have been changed separately. And now you'll see, yeah, they've been pulled down quite a bit. So if I show you what this does, let's do distortion amount. You can see it's distorting kind of that bottom level, but it's also distorting it within the pattern. Because we're using the same pattern to distort, it's actually distorting the pattern. And it makes it look like the pattern is not being cut completely in half. It's actually cutting it within the polygons because of the way that pattern is being used. So it kind of gives it a nice, cool looking edge. And we can raise and lower this. It looks like 17. I'm just going to flatten that value out. Looks like 17 is pretty good. If we were to increase it, you can just see it just keeps going. We don't really need it to. Keep it around 17, 18. 18 actually looks cool too. All right, so now we have kind of a really cool pattern. Let's set our MPC back. Should be the end of our material. Now we have our distortion, and remember our distortion kind of sits alone, and we're passing it through those reroute nodes. Go. MPC will set back down to 0. And now our overlay material is officially done. Now we'll move on to the material for our particle systems, for those particles that spawn over the top of the character. So let's hop in. All right, let's go ahead and do the material for our particles. So let's kick it off. And we will just call these poly particles. Now, these particles are going to be used in multiple different places. Because we know we're going to do multiple effects, instead of, again, going through the MPC and doing it per effect so we don't need to come back, we can just drop in the same logic we set up. Let's just go ahead and finish out our MPC. We know the effects we've been assigned to do. We've been assigned to do these respawns, the ammo, the laser beam, the plasma blaster, the shield, and the grenade. And we also have enemy turrets that are firing as well, and we're going to be changing colors for those. Now, we have two different ammo types. So we know that we have our laser beam and our plasma blaster. So we're going to create two different colors for each one of those. So our plasma blaster is blue, and our laser beam is, we're going to start with orange. And we can change these to whatever colors we want, honestly. So my first one, plasma. Actually, let's do laser beam first. These, I'm sorry. Ammo pickup, color 01, because that's the next effect that we're going to do. We'll start with our laser beam, which will be orange, and then we will do ammo pickup, color 02, and we're just going to do a blue plasma. And so we'll reflect that in our effects. So we'll call the first one the hero laser color, and that is because our enemy is going to be our turrets, and they're going to be a different color. So I want to make sure our hero color is one way, which we already said ammo pickup 1 is going to be our hero laser color, so it's orange. And then, and again, I know these are already set up. I've kind of preset some of these colors, but you can choose whatever color you want. If art direction, we're art directing these, let's say enemy colors are red, hero has orange and blue, depending on the type of effect that's being kicked off. So you want to use color language that's based on the communication you want to send to the player. So for us, we have orange and blue, and enemy laser color, which is red, and we have our plasma blaster color, and again we're just going to stick with blue for that. We will also do our shield color. Now our shield will have kind of an energy and then kind of an outer glow energy as well. So we have two different energy colors for the shield. Shield energy color 01. And we'll start off with blue. And then shield energy color 02. And we'll do orange for that, because orange and blue look good together. All right, and then finally, we will do our pulse grenade color. Okay, and we'll do blue for that as well. Because blue, you know, electricity, it makes sense. All right, so now we have all of our colors built out, and this will make it easier for us. You go to the right material, materials. We'll make it easier for us once we get to the other materials, especially since this is a base material, and I'm glad I said that. Base, and we'll just be iterating off of this material for some of the other ones. Actually, let's grab the texture first. We need our polygon texture. And we're going to be breaking off of this. So let's convert to parameter, polygon texture. There we go. All right, so let's just build the color, and we know our major shape is in the red channel, and let's see how that looks. First of all, let's grab our MPC from our global, and we're gonna start, since we're doing a respawn, we'll start with the respawn color. We'll just multiply this, just do a quick test. Oops, red channel, emissive color, and this is also an additive, by the way. Unlit additive material. There we go. Okay, we have our polygon. It's looking good. All right, we have our respawn color, and then we want to go next to our ammo colors. Now I just want a switch that I can turn on and off from each material instance that we instance from these particles. So let's use a static switch parameter, and we're going to call this one use ammo colors, because our base level is our respawn. So we're going to go in the hierarchy of the effects that we're going to do. So if it's false, you can use the respawn color. So next, it's going to go to our ammo pickup color 01. And then let's also use 02, because we have two ammo pickup colors. Okay, now how are we going to get from one color to the other and put it into true? We could do another switch, but I want to actually do something different where I have more control in, blueprints and other parameters. You can't really call a switch from a blueprint, and you can't call it in Niagara either. So it's a lot easier if we lerp these. So we'll hold down L and we can just lerp the two colors. And I'm going to set a scalar parameter, and I'm going to call this lerp to ammo color 2. So it's going to start on 1, and we can use this we can use it like a 0 to 1, but this gives us a scalar parameter we can expose anywhere. We'll send that to true. Okay, then the last thing is, we do also need this for our plasma blaster. So we want to set this up. I don't think we're actually going to use this in our electrical arcs. I think we're going to use sparks for that. So we don't need the electrical arcs color, but we do need our plasma blaster color. And we can do the same thing. We know that's coming after the ammo. And we can use plasma blaster color. Okay, so now we can set this in each one of our material instances. That should be good. All right, so there's a little bit of future proofing there. There's our color. Now I realized one thing I did not do in the previous material was set groups. Not always important. I know I kind of stuck with that in the first material. I will do that in production. So if you feel like going back and doing all the groups for each section, that's fine. All right, so the next thing is getting to understand what we want out of this particle. We could leave them like this, but I think it's really cool if they have kind of a blinking feature so that it shifts back and forth. It looks like these particles aren't just hanging static particles, but they have some sort of electricity, or they're alive, they have like a current going through them. So I want them to blink, and that's why I got that erosion texture, which is in our blue channel. So you can see we have that erosion, and I'm going to be using that to kind of animate these particles just through time, not necessarily through dynamic parameter, but just through time. Before we do that, let's go ahead and boost. I always like having an emissive intensity parameter. I know we're going to use these in particles. We don't need to really test emissive intensity, so let's go ahead and just create our dynamic parameter, emissive intensity. There we go. And now we should see the same thing. And now I want to be able to blink these particles on and off, if you will, and kind of leave maybe an erosion, but allow them to kind of blink between our outline and transverse back and forth. So the first thing, I know that I'm going to need time, and that's all that I want them to do is I want them to blink at a certain speed continuously. I'm not trying to animate the blink or do it on and off. These are just going to blink continuously. So I'm going to multiply this, and I'm going to do kind of a time multiplier. That's what I call it. So at 1, it's just going to blink regular speed. And they'll go nice and fast. I'm going to send this through a sine to get it to actually start blinking. So you'll see there's the blink. And then if I slow it down, it'll go a little slower. So at 1, this is our blink speed, just going from 0 to 1 back and forth. Now, if I send this through a cosine, and see what happens here. It starts to blink a little faster, back and forth, and I'm going to use this to kind of randomize the blinking. So I'm going to send this through a lerp, and I'm going to send the cosine as A. I'm going to put sine as B, and I'm also going to use sine to lerp between the blink. So at one point it's going to blink a little faster, and then see it's going to kind of stop and hesitate a little bit as well. So now I want to kind of remap these ranges. And I want to say, if I debug these scalar values, we can see what is being done here. You can see the result. Let's just see what numbers we're getting here. So it's going into the minus. We can see it's going up to around 2. All right, so let's create an absolute here. That way we keep the values positive, kind of between 0 and 2. And so I want to remap this range. I want to give it a little bit of a higher value so that it's not just cutting this off. So right now it's going up to 2 and then back, and then 2 and then back. So if we were to send this into a power, because ultimately this is what I'm going to do to control the erosion. See, blue is our erosion. We're going to send that into the base. And this is our exponent for the power. Now 2 is just not enough. So you can see, oops, get rid of the debug values. You can see it's just not eroding enough. So I need to give it more. And the way I'm going to do that is I'm going to remap these values to go up to a higher number. So let's go remap value range. Okay. And my input is going to be our numbers going in. And I want the low end. So let's say if this did still dip between negatives, if I didn't do the absolute value, I could still just use 0. And that would be our low. It would never go beneath that. I'm telling this that the low value is 0. There's nothing else. I could choose 1, whatever I want. But the low value is 0. The high value, because we know it's going to 2, is 2. But I could also change that to 1 so that it doesn't go all the way to 2, and then we can give it a new value from there, and you'll see what happens in a second. So the target low is just going to be 0 because that's going to be full. If you send it into a power, it's going to be full opaque, basically. You're just not going to clamp it down or erode it too much there. So then the high value, I'm going to give it, and I'm not going to send this as a scalar parameter. I want to predetermine this. Let's just go ahead and go high like 50. So now this is our target high value, and you'll see what's happening here. See, it's going back and forth, and it's giving us that nice kind of flicker. Now if I set this at 1, see how it doesn't quite flicker as much because it's going in between and kind of killing off that 2 value. So it's got kind of a cool flickering effect kind of going in between it. And so that's how I'm going. I could go higher, and then we're seeing kind of go all the way, but I just don't want it to lose I still want it to have a shape. So 50 is kind of a good threshold. Now let's take that, and that's going to be our opacity mask. There we go. And if we were to boost emissive intensity, let's say to around like 100, you can see what that looks like being boosted as well. Now, while I'm using blue in the power, I also want to use it to erode out kind of that red polygon. And we can see what that looks like. It's not going to do much. It's just a little bit, but I'm using it to kind of be the mask that that red polygon is on. You can see how sometimes this edge disappears. I want to keep that outline. So I'm going to add the outline to this so I never lose the outline of the shape. So it's just eroding the interior. And so now you can see we have rigidity and still keeping the shape itself. So now I also want to control that blink, and I want to be able to turn it on and off. There may be a time I want it on, and then I want it to intermittently be used. So I'm going to set up a lerp, and I'm going to go ahead and put the red channel on the top, because that's where I want it to be normally. And then I'm going to put this in the bottom, and I'm just going to control through the dynamic parameter the blink on off. Okay? And I'll send that into the alpha, and now it will either blink or it won't blink. Now, because it's set to 1 by default, you will see that it will blink. There, it's off. And now I can control this in the particle system and kind of intermittently use this if I want. If I turn it on, then it blinks. All right, let's get rid of the debug scalar values. Let's kind of pull these back, organize this a little bit better. All right, this is our blink timing. Now I got on myself for not grouping these together the last time. So let's just go ahead and do that, because these will be instances that we use. And remember, these are static switch parameters, so they are also being called in the instance. All that's good. There's not really anything else. And then we can just set this up as like, I'll just put this under animation. And we have a time mult. Again, there's not much to really group here. It's just for the sake of being organized and being consistent. There we go. All right, let's go ahead and jump into our particle systems. Okay, so in this next section, we're going to go ahead and make our first Niagara particle system, and we're going to be taking care of the spawn energy from the center of the platform into the character. So let's go ahead and get started. Okay, so back in our level, we're going to go ahead and go to our respawn effects folder. Under particle effects, we're just going to go ahead and create a new Niagara system. And I'm going to say from selected emitters, and we're just going to do an omnidirectional burst. Just something that spawns once. Doesn't matter that there's a ton of particles. We're going to kill a lot of stuff. And I will just tweak this system. I just like to pick an emitter that gives me enough to work from, and then we can kind of work backwards from there and delete things as necessary. So we'll just say Niagara system, NS. And we're going to call this just respawn effects, because this is going to take care of our entire respawn effects in our particle system. So let's open that up. All right, so what do we have? We just have these burst particles. So let's go ahead and start getting rid of things. We know we want to spawn a mesh. So the goal of this emitter is to spawn that disk mesh on the platform exactly where we want to spawn it. And we just want to spawn it once. We want to animate our parameters, and then we want to kill it. So we already know it's going to spawn once. We're going to spawn one because we're just spawning one disk. We're going to turn off gravity. We can kill gravity, just delete it, delete drag. We don't need that. We don't need to scale a sprite size because we're going to kill this sprite renderer in just a moment. So we can get rid of that. And we will go ahead and just add a new renderer. So let's add our mesh renderer. Let's get rid of our sprite renderer. And also there's a velocity going on. We want to go ahead and kill that. We don't need any velocity. We may keep the shape location, but obviously we don't want it to spawn in a wide pattern or off center of an axis. We want it to spawn right at 0. So I'm just going to take the sphere down to 0 in case we use this, and if not, that's okay. We'll play around with that. All right. What mesh are we going to use? Well, we've already created our meshes. So if you hit Control Space, we can bring this up. And we'll go to our Scififx, respawn, and our meshes, and we know we're going to be using this disk mesh that we created earlier. So let's come back over to our mesh and just go ahead and hit the selected asset from content browser icon, and now we have that mesh. And we're going to go ahead and enable material override so we can use a custom material. So let's add that in. And we'll use the material that we also created for this, which is our energy platform base. We don't need to make an instance of it. We're not going to be using multiple instances. Sometimes I like to use an instance just so we can expose parameters and turn those on and off. But we can also expose parameters in our material. So let's say we're only using it for this one effect. We can expose whatever parameters we want, and we will do this later. We don't necessarily need to do it now, but if you come down to these material parameters, you'll see we have attribute bindings, we have scalar parameters, vector parameters, and texture parameters, which means we can swap out textures in our material, so that's safe. We can call any vector and scalar parameters we've set up and just hard code them right down here, or we can do the same thing. Attribute bindings pulls from scalar and vector parameters, but we can basically tie them to a user parameter we set up, and we can call those user parameters anywhere in here to affect our parameters from our material. So technically, you can handle all of the stuff you would want to change in the instance minus things like a Boolean parameter or a static switch parameter because they don't read over here. So if you did want to affect, hey, I want to turn this on and off, then an instance is probably necessary. This will all make sense later, but I just wanted to kind of briefly highlight that we will be using that at some point. Let's just grab our material real quick and pop that in our material overrides. So we can now set this up with our dynamic parameters. So let's go ahead and add a dynamic parameter. And we know that animate energy is what we're going to want to animate. So let's go ahead and add a curve. We'll say, oops, float from curve. We can go ahead and just take the first value down to 0. And I'm just going to keep this simple. Let's start with it up at 1. Just go 0 to 1. And I like to use break because I can control the handles individually. So I'm just going to keep it there. And I will keep the curve value where it is. And let's see, in our scale color, we have our alpha. I want the alpha to kind of trail out quickly, so I'm going to pull it down. Now, I've kind of already played with these values, to be fair. I don't want to scale the RGB, so I kind of know where I want to go with this, but honestly, it's going to come down to what you need. So in order to test this right, let's just pull this aside, and let's pull this in to our level. Okay. Now we can see, in order to test this, let's take this back from once to infinite, and this will just keep spawning. So right now we know it's going the right direction. It's animating from the outside in, so that's good. But we're not quite as far as we want to be over here. And also our mesh is too small. So we need to make sure we add a scale mesh. Actually, we don't need to scale the mesh, I'm sorry. We just go to initialize particle. We'll go to the mesh scale mode on our initialized particle, and we're going to just choose uniform. Right now this is our 1, so if we scale this up a little bit, we can see how far that is going. And then the goal is to see how far we need to animate this before we reach kind of the edge of that. So lifetime is probably random right now, which is not good. We just want a direct lifetime. We can do 1, but we need to increase our value of how much this animates. So right now it's just 0 to 1, which is pretty slow. If we increase our scale curve by a value higher, you can see we get a faster animation. And now you can see we're also coming out of the edge, but we're still not to the edge. So let's just increase our particle mesh a little bit more until we reach about the edge of the glass. Now we may have to get a little higher. Let me take this to, see if we go 0. There we go. If we just send it to 0 right now, we can freeze it and see where it's going to start. So right now it's starting kind of right where we want it to, right at the edge. And then it is animating in to where we want it to go. If we scale the curve up again, we'll go ahead and be able to animate right in there. There we go. Now, let's say these bands are a little too thin. Then we can increase this size. So I'm going to do something. Let's build a user parameter. And we're going to do a float. And we're going to call this bandwidth. Okay. Now, in order to figure this out, we're going to go back into our material. So we know bandwidth is a parameter, and it's set to 0.1 right now. So we'll leave the default at 0.1 over here in our user parameter. And we're going to bind this attribute in our particle system through our material parameters. So let's go ahead and add an attribute binding. This is the same thing as a scalar parameter, but if I use a scalar and I say bandwidth, I can only hard code it here. I can't drag this over and let this be a parameter this reads from. So this is just a hard code. So if you just want to change the bandwidth without setting a parameter, you can. And we can say 0.2, and our bandwidth will be thicker. So we could do that because we don't really need to control it from anywhere else. So this user parameter is not really necessary. But let's say we did want to, just so when we pop open this particle system, we don't have to look for it. And that's another reason why I like setting up user parameters, because I don't have to go in, find the material, and look for everything and do that. So it's yelling at me because I've set up an attribute binding that's not bound. So let's delete our scalar. Let's go bandwidth for our attribute. And now we have this bandwidth user parameter over here we can call, and see it shows up right down here, bandwidth. And so now we can control the bandwidth just from this user parameter itself. And if we wanted to, we could technically expose this in a blueprint and control it from there. So you've got a lot of flexibility by opening up this parameter and binding it. Okay, so we want it to go just a little thicker. Let's do 0.2. And we'll save that. And there we go. Now we have some cool scrolling energy. It's not just being sucked right into the beginning. We do see that it's kind of coming outside of the lights a little bit. So we might want to push that scale back just slightly. Yeah, see, it's kind of dipping off the edge, if you can see. So let's take the scale back. And what are we at? 1.4? Let's go 1.35 and we can adjust from there. Let's see. Now that's not bad, because where it's starting is where our light is going to happen. So there's going to be a light up right here, and we'll adjust that in our blueprint. I'll show you that next. We haven't gone through that yet. But these are lights in the rim. This is going to light up. So the fact that the energy is coming from this is totally fine. That looks good. And there we go. Now we have our scrolling energy that is going to be absorbed by our character and sent up through the core of our character. So next, let's go ahead and work on those spawn particles that attach to our character after the energy is complete. Okay, before we jump into adding our next particle system, let's just go ahead and rename this so we know what it is. So this will be our scrolling energy disk. Okay, now we're going to add another emitter, and we're going to do the same thing, add an omnidirectional burst. This time we're going to have some sprites, and we're going to be leaving some of these parameters alone. We don't really need velocity, and we don't need the shape location because we're going to be spawning off of the skeletal mesh itself. So we can get rid of shape location, we can get rid of velocity because there's no velocity needed. Currently, we're going to disable gravity and drag. We will come back to those later. And then we will still leave some of our other options available at the current time. First thing though, we're going to make sure these are GPU emitters because we're going to spawn quite a few of them. And we don't want to tax the CPU. The GPU will be able to handle these a lot better. So let's go ahead and move this over to a GPU sim. And let's increase our bounds. So changed it from dynamic to fixed. And this is too small of a bounding box. They'll disappear quite easily. So I like to usually set them around 5,000 just so they have enough room so that they don't just disappear from the scene when you kind of look away. All right, there we go. Next thing we're going to do is we're going to send our material for our particles into our material right here. So let's get our polyparticles base, and that is now our material. And then we're also going to spawn this through, instead of a skeletal mesh, we're going to spawn it through an initialized mesh reproduction sprite. All right, and we're going to say attach to parent because what we're going to do is we're going to have this particle system living within a blueprint, and the parent is going to be our Wraith character. So we need to make sure that we have the blueprint set up to where the Wraith character has this particle system attached underneath, and then that will become the parent, and this will automatically take any skeletal mesh of whatever its parent is. So if we wanted to repurpose this system and we wanted to add a new skeletal mesh, then we could just tie it to a new skeletal mesh by adding it as a child. However, we're going to go ahead and use our Wraith character as a preview mesh just so we can see it spawn of how it's going to look in our editor. Now, I'm going to just hit the G key to get rid of these overlays. And if I save this, I haven't saved it yet, so we won't be seeing it in our level. Now you can see it in our level, and you can see that we have those cool looking little particle spawns happening. I'm going to change this to infinite as well, just so I can see it happen over and over again. Just kind of can make sure it's kicking off. And I want to change this to something pretty high, maybe like 5,000. Seems like I'm going to 5,000 quite a bit. And you'll see we get quite a few particles. It actually looks kind of cool. And you could use that as the effect too, if you'd like. But we're going to take the scale down just a little bit more. So I'm going to go into our initialized particle, and under our sprite particles, I'm going to set these low to like 1 and 2. We should get a smaller scale there. All right, also in the lifetime, actually the lifetime is fine. We'll leave that alone for now. I think we have everything set up under our initialize, so that's good. Although, I'm just going to change the max particle size to 1. That way it goes down a little bit more, and now we have these smaller particles. So we don't have to worry about it. So even if I go, let's see, yeah, should just leave it at 1. So nothing higher than 1, but we could do like 0.75 to just add a little bit. Maybe. I'm just going to go to 1.25 because I like the size of these. They're looking pretty cool that way. All right, so now the goal is to make sure that these particles have some sort of activation. And what I mean by activation is after we spawn in, then I want them to drop to the ground. And so we need an activation for that to happen. So I'm going to build in a user parameter here, and we're going to do a curve. I always get that backwards. All right, curve for floats. And I'm just going to call this activation curve. See? I can't get it. Can't get the E before V. I think there's a rule about that. All right, I'm going to start at 0.5 because about halfway through the life of these particles, I want them to start to fall. And I'm going to go ahead and just push this to like 0.75. I don't necessarily want it to go all the way to 1 because by the time it gets to 1, these particles are going to be gone. So I want them to still be falling and colliding and interacting when they still have some life left. So I'm just going to push this to probably 0.75. And we're going to say we want to go up to just 1. So this is just a 0 to 1 curve, and we can change values from there. And we're going to use the curve for multiple things. So the first thing we're going to use it for is our gravity force. So we have our gravity. We have it set to minus 980. So that's usual gravity. And that's just going to allow them to fall. But as you can see right now, they're just going to fall immediately. So we want to set our gravity to be multiplied. So we want to multiply this by a float. And let's just reset our parameters here, minus 980. And you can see if we set this to 0, nothing happens. And if we set it to 1, okay, we're good. So we're going to want to change this to a curve. Float from curve. And our curve is going to be our activation curve so that these spawn in and then they fall. And there we go. We have a cool little way to activate our gravity. Now we're going to do the same thing for our drag, except I want to have a little bit of control over the drag. Let's see. The drag is actually going to start at 1. So we're going to kind of reverse this. So we're going to set it manually. So let's first do a float from curve. And this is going to be at 1 to start. And then at 0.5, we're going to release the drag. So the drag is going to be high so that the particles don't just fall and they have some tension here. So we'll set that to 1. And then we know that at 0.75 we want them to go. So let's go ahead and move this to 0.75. And 0 is good. And then we're going to set the drag very high to keep this, to keep them kind of frozen in place. So I want to add kind of a random range for this. It's not going to be much of a difference, but I'm going to set this to like 25, 25, and 35. And now our drag is very high, but it's going to dissipate and we're not going to have any drag towards the end of these particles. So if I use this, if I just do this once, let's see what's happening right now. There you go. So on spawn, that's what's happening. They'll reset. Let me move this in here. Oops. There we go. Okay, so now we have our drag and all of that set. Our particles are also going to scale. This was kind of set up. I don't want them to just scale, scale sprite size. They're going to already scale down as they kind of go towards the ground. So they're already getting smaller. So that's kind of cool. I'm not really going to mess with that. I like that. The alpha is fine. We can keep all this the same. The next thing we're going to do is we're going to add collision because we want these particles to collide with the ground. So let's add collision. There we go. And we're going to make sure that some things are working in here. Instead of depth buffer, let's do distance fields. And this should help. Let's change this back to infinite. Let's go back. Oops. Save that. Let's see it spawn. And there it's colliding. It's a little slow right now. Let's let it kind of buffer. There we go. You can see it colliding with everything. And by using distance fields, we're really using kind of the area around it. If I use depth buffer, let's see what that will do. Let's see if that works better. The distance fields kind of just hug the mesh a little bit better. So let's use distance fields. Okay, so now we have our particle emitter set up. I think that is about all. We may change the intensity of this energy. So this may not be bright enough to give you all the visual information of the energy really going into this character. Let's just go ahead and make that parameter now. And again, that's going to be an attribute binding. And we know emissive intensity. And let's create another user parameter. Actually, I can just create it here. So float. And we'll change this to energy intensity. You could call it emissive intensity too if you want. And I'm going to pump it up to like 50. And let's do this. So at the core, it's going to be really hot, and towards the edges, because we have that sphere mask, or we have that radial gradient exponential mask on it, it's going to be more blurred. And there we go. We have our nice parameters, and globally, we have, if you remember, our material parameter collection. So if we were to change this respawn color to something like red, you should see it affect and go to red. So we're not changing, obviously, any of the color values in the particle system because we want to have a global control over that. And so just know that we can already change those values. All right, we may come back to our particle emitter again. This is to kick it off and just see how everything's looking. And right now this is looking pretty cool. But we won't really know how all of this feels completely until we get our blueprint established. So we've got a good sense of how these things are working together. And we'll go ahead and start working on our blueprints so that we can make this final and then do any additional tweaks that we need. So we'll just make sure we save it all. And we should be able to start prototyping our blueprint logic. All right, so let's go ahead and hop into the next section and start working on blueprints. The first blueprint we're going to set up is not going to be the character blueprint. We're actually going to set up our level blueprint first because we want to add a couple of features that will make this easier. So first is necessary because we want to have a respawn key that allows us to start the level over and respawn our character. This will also allow us to test the character. The second input action we need is a slow-mo feature. Why is a slow-mo feature or a retiming feature necessary? Because sometimes in a game you're working on, you may have some sort of retiming mechanic, whether it's to send time back and forth or whether it's to slow down combat or gameplay for a brief time. If you remember Max Payne back in the day, that was a game kind of famous for setting that bullet time mode. Now a ton of games have copied that. So slow-mo can be really important, and it's also really good to test our effects in slow motion to see how they're kicking off. Do they still hold up when they're slow, or do we need some work? Because a lot of times you can kick effects off really quickly, they look great, but if you have a slow-mo mechanic, you can see all the flaws and all the weaknesses once you start to slow down the time. So let's go ahead and open up our level blueprints. And we are going to use an input action that has already been defined in this project. It should just be called respawn, so we can just call that. And again, if you remember how we set that up, just go to the project settings and say action. Get to the input actions, and you can see down here under respawn, we've just added a keyboard shortcut for R. So the key to use for respawn will be R, which makes it easy. I'm not going to be doing any reloading or anything, so for us, this key works. So what we want to do in order to do this, it's a pretty simple setup. We just want to get our current level name because we're not restarting anything. We're going to basically reopen the level is what is happening. So we want to get current level name, and then we want to open the level by name. And so we will just connect this, and then we'll just go ahead and connect the return value, and it'll automatically convert for us. And that's it. That's simple as that. So we will label this respawn effects. I'll just give it a cool little color. There we go. And the second one is also simple. This is going to be our slow-mo functionality. So we're going to actually set a key for this, and we can change this. I didn't include this in the input mapping, but we're going to just use the Z key And basically we want, when we press this, we want it to go into slow-mo. And when we press it again, we want it to stop slow-mo and go back to just our normal time dilation. So I'm going to use a flip-flop because that will alternate on key press. So Z will return A, Z again will return B, Z again will return A, and so on. It just keeps going back and forth as long as the keys are alternating. And then, like I alluded to already, we're setting the global time dilation. So let's just do that, set global time dilation. And we want to set it to around 0.2. So 1 is normal time. And then we're going to duplicate this time dilation. And on B, we're just going to reset it to 1. There we go. Do the same thing, hit C, add a comment box, call this slow-mo. And I like red, kind of a reddish pink. Okay, there we go. Now we have our level blueprint. And if we hit play, you'll see we've got, our particle system going over there. But if we hit R, we restart. Every time we hit R, it restarts. And that will be what is kicking off and driving our particle system. And then you can see once I hit Z, we go into slow-mo. If I hit it again, we go into regular, slow-mo, regular. So it's functioning, both are functioning as normal. And that's it. That's our level blueprint set up, and that will be useful for handling kind of all of our effects that we're going to be doing. Let's head over to our next blueprint, which will be through our character blueprint and setting up all the logic we need to kick off our respawn effects. All right, let's jump into our character blueprint here. So we have already got our effects kicking off. Now, we have them set to infinite right now, so let's jump back to our particle system really quick and just make sure we have these set to once. There we go. And I also want to make sure that when these kick off, we need to make sure that we have a delay set so that these particles don't hit right away. So I'm just going to go ahead and give them a loop delay. I'm going to say I don't quite want 1 second, but I think maybe let's give it half a second and see what happens. It might be enough time for our character's material to kind of loop up through there. Maybe 0.6. I'm just trying to let this energy disk finish before it kind of gets to, okay. That's enough of a trail off. Let's see if how that timing works, and we can always revisit it later. All right, so now let's go to our character blueprint. And first thing we're going to do is just set up our respawn logic. You can see once we come into our character blueprint that we already have our input actions dropped just to save time. And then we have some audio components. You don't need to know this. This is just audio that is going to be hooked up. Thank you very much to my incredible friend, Brian Michael Fuller, for all the sound design. So he has set up all the logic for me, and those will just be living in some of these blueprints. But we will be setting up the logic ourselves. So you can see right here I have event begin play needed for respawn, because at the beginning of our level, as soon as we hit play, we want those to kick off. I'll go ahead and delete this comment. But we also want to make sure that every time we respawn, that they kick off as well. So event begin play is really going to happen right away. And we can check to see if that will always work. And if it will, we don't need the respawn logic to hook up. But if for some edge case it doesn't, it trip correctly, having the input action respawn won't hurt us as well, because we technically want it to fire on both of those things. So the first thing we want to do is, like I said before, we need a parent for our particle system to live in. So our mesh is our character mesh, our Wraith character mesh, and we want to go ahead and add our particle system. Let's go to our respawn effects folder and just go ahead and add our particle system. It's already called respawn effects. And we want to make sure that this is under the mesh as its parent, and it is. So now we have a parent And I think we can go ahead and make sure that this is just parented to the root. It's not going to matter. We don't want it parented to any other bones because we want it, attached to the root so that this particle system kind of follows. So let's just come over to sockets, and we're on our particle system here. We type this, we can find root, and we just want to use the root bone. And let's go ahead and drag our particle system in here. So we set that up as a variable. And we're going to make sure that we activate this particle system as soon as we begin play here or hit our respawn effects. And then we want to make sure that after it kicks off, we destroy it. So let's go ahead and also destroy component, but we don't want it to destroy right away. So let's make sure we set a delay. And the particle system lasts around 3 or so seconds. I'm just going to give it a delay of 5 seconds, and that's just going to make sure it kills it. So it'll be dead. There'll be no more particle system that's just still there, just not activated anymore. So it's just a good cleanup practice to make sure we destroy that component after about 5 seconds so it doesn't live. And then we want to just hook it up to our audio. And that should be good. Now, one thing we need to make sure of is we need to make sure, now that this is being spawned in, that we delete it from our level. So we know that we have the respawn. If you check our outliner, we have our respawn effects over here in the outliner, and we need to just delete that because they'll kick off right when we spawn 2 and it'll be double. So just make sure if you're testing in the level and you've tested it exactly where you're going to spawn, that you get rid of that extra stuff. So now that we have all that hooked up, let's go ahead and play, and we should hear our respawn effects, and we should hear any other level audio that is being called in this, like our score is dropped in. By the way, I think I've already said this, if you don't want to hear the score or the ambience, you can just go ahead and delete that and you can add it in later, and I think I've shown you where those locations are. Okay, so when we spawn this in, and oh, there's the sound. So you can hear that the sound is actually disjointed from this. And that's because we added the respawn audio after the delay. So this is important, and in some way I'm glad this happened because a lot of times you can add in logic. So let's say that audio was already hooked up and we come in here and someone, just a prototype, the logic is set up and we add a delay. Well, now the audio is spawning 5 seconds after it should. Now we could put this audio component before the delay, write it activate, but I want to make it a little cleaner. And so I'm going to show you something that I do quite a bit, which is just add in a sequence node. And we're going to hold control and drag. And then we're going to send then for the first part of the sequence into the activate. We're just going to hold Alt and click and delete that. And I'm just going to move all this over so we have a nice clean little tag down here. And now when we spawn in, we should hear, there you go. Now we've got our cool spawn in sound. And if this is too intense, we can always take it down on the volume multiplier. This isn't a lesson in audio, but just something to make it a little, yeah, about half that volume's good. There we go. So let's save. Make sure you're always in your map. You can save here and save all. So we save our level and we save all the progress that we've made inside. So everything's kicking off. Everything's looking really good. It's right where it needs to be. Now we can also test this through slow-mo. Let's go ahead and just test it R and Z really quickly. All right, so we can see that our circle is still dipping off the edge just slightly if you look out there. It's coming off the edge slightly. And I need to make sure that doesn't happen. So let's go back into our emitter. And let's change that. Let's just scale down our energy. And let's do maybe 1.2. Here's where we need, I actually like the emissive intensity on this. There we go. Perfect. It's coming from the lights where we want it to be, and that's good. Okay. And now our logic is set up for our player character. All right, so that is our player character blueprint with our respawn logic. Now you may be thinking, hey, where's the overlay material? We haven't kicked that off yet. That is going to be controlled through our energy spawn platform. So we're going to go into that blueprint and we're going to do all of the animation to be able to kick off our overlay material through a material parameter collection. And I don't want that to live in the player blueprint because we've got timelines and things like that. So the player blueprint I want to keep clean, and we need the particle system to attach to the player. So that's why we've set up the logic here. Now, first of all, though, we do need to make sure that we set up the overlay material in here because it has to go on our player mesh. So let's go ahead and search, go to overlay material. Let's hit Control Spacebar and we can go to our materials, and then here's our overlay for our Wraith material. Now, this is an interesting one. I do want to make a material instance of this just in case we change out a texture or we want to add, something different. There's a little more complexity to this. There's some additional parameters. So we're just going to change this to material instance, call it Wraith Respawn Overlay 01, and we'll save it. And we will just go ahead and put that in our overlay material. And so now we actually have our overlay material on our Wraith character. Nothing's happening yet because it's basically off because we haven't animated our parameter to bring it up onto the character yet. And we will do that in the next part of this section. First thing we're going to do is we're just going to make sure we have our material parameter collections set up so that they're kicking things off the right way. So our respawn platform, if we can just go right here and edit the blueprint from the outliner, or you can go into content, Scififx environment spawn platform, and open the blueprint from there. Either one will do. And you can see we don't have our logic quite hooked up yet, but we want to make sure that our materials are working first. So if we go to our spawn platform, we're going to go to our base material. And inside of our base material, let's open it up. Let's go to the actual location. Let's open up our base material. And you can see we have a color for our lights. This is our light color. And it's a little less organized in here, but if you can follow with me here, emissive intensity and our light color are two things that we want to change. Now, why do we want to change this color? Because we want the lights to match our respawn effects. And in order to do that, we need to get our material parameter collection from our global folder and drag that in and choose our respawn color and just go ahead and connect that. You can get rid of that material. And now any color we change our respawn effects, they'll change the respawn color, but they'll also change the color of the lights on the platform. So that's handy. And then we also want to animate our emissive intensity for the platform. So let's go back to our Scififx folder for respawn and go to our materials. And we're going to go to our MPC for our Wraith respawn. Right, so we're going to go ahead and add one more scalar value here. And we're going to call this our platform emissive intensity. There we go. And we'll just start off with kind of our base value. Let's see, what did we give it? It's at 0 because it's not starting there. Just so we can see it, let's add 5. We'll turn it off in a minute. And then in our spawn platform blueprint, we're going to want to make sure that we have our parameters in here set up for what we want to control. So we know that back in our material for our respawn, we go back in here and bring this up. We know that we had set up kind of an offset. And the fill is going to fill the main pattern over the top of the character. And it's also going to have a slight offset for that, for the outline layer that's going to permeate through the character as well as kind of a secondary. And then we're going to empty that respawn. We also have an erosion, but the empty is also going to bring that respawn kind of through the character, and then we're going to have kind of an erosion out. So that's 1, 2, 3 parameters we need to animate. Plus, we also now have the platform emissive intensity. And that way we can turn on and off the lights for the platform and have those dissipate as soon as our particle system kicks off with that energy. So we want to animate the lights first and kind of get that timing down. And then we will animate the overlay material on top of the character. Now, before we do that, let's go into our particle effect and just turn everything off. By everything, I mean not everything, just the scrolling energy. We'll leave the scrolling energy disk. We're going to turn off the particles. Also, I forgot that we did not rename these. Let's go ahead and just rename these now and just call these energy particles. Okay. So let's turn those off so that it doesn't kind of cloud our overlay material, and then we'll set up the timing in just a little bit. So first things first, in order to animate, we need to add a timeline. All right. And we'll just call this energy animation. And that's just going to kick off on event begin play. And we'll play kind of from the start each time. So we know we want to kick off our platform emissive intensity. We also want to animate our respawn fill, our respawn empty, and our respawn erosion. Okay, now the goal for these is we want to make sure, for the most part, we keep everything 0 to 1. We don't necessarily need to change high values in these graphs. It can get cumbersome to kind of look for a higher number and actually animate that correctly with a curve and all of that. So we'll do a lot of multiplying and using additional numbers outside of the animation timeline. But for the most part, we just want to stick with adding everything within that 0 to 1 range. So let's start, before we get into all of it, let's start with our platform emissive intensity. So we know that they're going to start at 1 because they're going to start on. So our platform will start with a key at 0, and it's going to have the value of 1. Let's change that in a second. And we're going to add another key, and we'll put that at 1 and 0. Let's make sure this is 1 and crunch that down. And I think I want to go ahead and just bring this down. Let's do our break again so we can animate these individually. I'm just going to right click and drag, and I like to kind of sometimes bring it out quick. It's going to go quick here. Okay, now you can see we have all our parameters set here. So the next thing we want to do is we want to start adding a way to set our scalar parameter values. So we know these are all scalars, and they're all coming from material parameter collection. So we want to set scalar parameter value, and we want to see, yep, this says set scalar parameter value on material collection instance, which is what we want. And then we want to define our collection, which is our MPC Wraith respawn. So let's define that. Now we should have our parameters pop up. So here's our platform emissive intensity. And we are going to define what our emissive intensity looks like. So in order to do that, let's go to our platform values here. And we can go to this material because it's a scalar parameter. So let's go to our platform and our platform base material. It's already up here. I don't know why I just went through everything. But the emissive intensity is not set. Let's see what 50 gets us. Let's see how bright that is. And I'm going to pull this down so that I can change this on the fly. Okay. So that's pretty bright. It's not bad. We've got our nice blue color. If I hit play, you can see that's a pretty nice emissive glow on those lights. If we kick it up any higher, let's see how far we can go with this. Yeah, we start losing kind of the color. It gets very glowy, and we definitely don't want to go super high. So maybe 150 gives us kind of a really cool glow, and then we can take it down. So let's set that back down to 0. Let's make sure that it is set to 0 in our material parameter collection. It's not necessary because we can set that in the blueprint to just be what it is, but usually it's a good practice just to set it at whatever the base value is you want so that it doesn't mess it up. Sometimes it's not, doesn't play well. So we're going to update that. We're going to say we want a variable now called platform emissive intensity. You don't have to do this here. You could just set the value. But in case I want to use this elsewhere or I want to change it on the master blueprint in the level, I'm going to say instance editable. I'm going to hit compile. Actually, let me just change this. Platform emissive intensity. And this way we can kind of call it wherever we want. And we're going to say this is 150. So now what we're going to do is we're going to take our emissive intensity and we're going to multiply. Because remember, this is 0 to 1. So as it approaches 1, it's going to multiply by our actual intensity value. So I'm going to just set that. There we go. So once it gets to 1, it'll be the full 150. I say once it gets to 1. It's going to start at 150 and go down to 0. So it's being multiplied by 1. So there we go. We'll start at 150. And let's just test this. Let's see if this is working. When we start it up. Okay, let's respawn. All right, it's not working. Okay, so we have an issue. Let's go into our material. Aha, guess what we didn't do? Or guess what I didn't do? I did not set up my material parameter collection for this. Actually, sorry, this is the master. Let's go to our Wraith respawn. Here we go. Now we can do our platform emissive intensity. Let's replace this value. You can delete that. So we need to make sure we put our material parameter collection if we're going to call it material parameter collection. All right, let's hook that back up because I guarantee you now it's going to work. And there we go. It's working. Now you can see that our emissive value was nice, but it's not playing well with kind of our post-process volume. It's kind of clamping those values down. So it's very soft. And it's not dissipating fast enough. So let's change this back to 1. Here we go. Respawn. I'm just going to test it a couple of times. Okay, that kind of blends well, but we need a higher emissive intensity. So this is why this is nice. We can go to our value. And now we're going to set it higher. And let's see what this gets us. All right. That's cool, but I really want this to glow. I really would love to see it glow here. So I'm going to go pretty outrageous, and I'm going to say 10,000. Seems outrageous, but this is just, we're finding the value that's going to work for our play. And you can see that even at 10,000, it's right where we kind of wanted it initially. Very cool. Also, what you can see is that it's lighting up our character. We don't have any particle lights in there, but emissive, working with lumen, emissive values actually work to help light scenes now. So that's an amazing byproduct. We don't need any additional lighting from our particle systems or point lights to be able to light up our player. So I think that is working really well. I think 10,000 is kind of our value that seems to work, and we have the timing set. And now we just need to do the overlay material for our character. Now we're going to use the exact same NPC. We're just going to call different parameters, so we can duplicate that 3 times to get all of our parameters. We've got our respawn fill, our respawn empty, and our erosion amount. Okay. Now we're going to have to make sure that we know how this is going to function here. So the first thing we want to do is we want to fill the player, and we want to test that timing first. So let's go ahead and create let's add a key. Start this at 0, and let's go to like 0.75. I don't want to go all the way to 1. And let's just go with 1 here. And again, let's change this to a break. And I want this to kind of be snappier, so I'm just going to pull a curve like this to test it and see what happens. Okay, so to get our fill, well, we have to know how high we're going to go on our fill so we know how far up to animate this. So we can test that with our respawn values. And if I put our blueprint for our Wraith character here, let's go back to him. This is how we're going to test and find out what our value is. We can stick our Wraith character right there. All right, so he's got the overlay material, so we should be able to see this happen. This is how I'm going to test it. So we got to go a ways. There we go. So we know that, and you can see our nice cool distortion working, by the way, and how it is expanding this pattern. We can see that by around 750 or so, it's there. But I want to make sure that if someone decides to jump right away, he's not going to come out. We also see, we can test our empty value by see how our erosion's working. That's so cool. I really like that. So we can see our respawn empties coming up, and of course we're just basically reversing that value. And then our erosion amount, we can set kind of however we want if we need it to work. All right. Empty. Now, you can also see, just so we can test this here, you can also see our pattern is offset. So notice how there's no outline coming through just yet until we get to a certain amount. Let me turn our erosion off. You can see our outline pattern here. That's why we're going to go higher, because our outline doesn't fully transition in until about 1036. So we'll go to about 1150, and just to make sure everything stays consistent, let's go to 1200. So our respawn fill is going to be 1200, and then to empty it all, we've got to go all the way through to 753. May not even need the erosion amount. I think we're just going to cut it out. I think our distortion is looking really cool, and it actually kind of erodes it. So I don't think we're going to actually use this erosion amount, but it's there in case we wanted to use it for something. So, and you can play around with some cool stuff if you'd like. But now that we've tested that, we know 1200, and we know about 850 is how high I'm going to go on the lerp out. And we'll set these back down to 0. We'll save that. Pop it back up there. All right, so I know I'm just going to kill that erosion amount. Don't need it. I'm also going to change that in the timeline because I don't want an extra thing hanging around here. So let's just, whoops, delete. I accidentally duplicated it. There we go. Oops. Did I? No, I just closed it. I don't know what I'm thinking. There we go. So now we have the respawn fill, which is going to 1 at 0.75, and then we need to make sure we empty it, and we can probably start emptying it right in the middle somewhere. So we'll bring that up and finish it out just after. So our value will be 1. Started at negative, let's bring that to 0. Again, let's do the whole break. Whoops. There we go. And just leave this alone for now. We're going to test this. Let's just create one value. So let's just make a parameter value, and we're just going to call this respawn height ceiling, which means this is just as far as we're going to go on the height of our respawn effect. Looks like I don't have to go all the way to 1200. Let's test it at 1100 first and see if it will fully transition. And again, we're going to multiply, and we're going to do our fill. We can just double click, bring that there. That guy. There we go. And I'm just going to steal this and do the same thing for the empty. And we can steal the same value. Let's double click to make this clean. And let's populate it over here. Okay, so now we should be able to see our character go through his 2 stages. Let me get rid of this character blueprint. We don't need it. Okay, now he's a little bright, and we also don't really get to see the fill. So we need to maybe back that up a little bit. Let's take this back to, let's do 1.25, and let's bump this back to about 0.25. And then let's just push this down. And then we need to take this probably to like 1.75. Again, I'm just trying to time this animation out, and starting this at 0.75, just in the middle of the animation. Let's see how that's looking. Ooh, that's getting closer. We can probably start filling it a little quicker than that. Now that we have it pushed, I'm going to go 0.1. Okay, actually going to flatten this out a little bit. Nice, and there's our fill. And then this probably should start closer to like 0.45 and maybe go to around 1.5. And again, flatten the curve out slightly, but not all the way, and let's see how that's looking. Okay, it's looking better, but I don't like how quick that's happening. Let's try this. Okay. I feel like that timing is getting a lot better. Now, here's what I need to change. So it's really harsh around the player right now. It's just kind of filling the player completely. I want to tone that down some. And the way we're going to do that is through our Fresnel mask. So if we come back to our main material and we go up to our Fresnel mask, we can see that our Fresnel amount is pretty low. Let's turn that up to 5. Let's just bump it up to 5. And I think, actually, let's go to our effects for respawn materials, our overlay. Let's actually do it here. It's bumped up now, but let's take it back to where we had it in this value so we're not changing it. We'll keep our default values. I'll leave those alone. And we're going to change that to 5. There we go. All right, so 5 is not enough. Let me turn off my sound so this doesn't get really annoying. You can see that it is not enough. Now it's too much for now. And probably a little too intense on our emissive intensity. Let's go to 2.5. Let's cut that in half. Again, this is all about dialing things in. That's better. However, let's check our material again. We have a boost second pattern, and I think that's a little too hot. Our second pattern is that outline. It's a little too hot right now. So let's take that down to maybe 15. It's very dramatic, so let's just double check it. I'm going to boost that just a hair more. Let's go to 20, and let's change the Fresnel down to 2 and see what happens. There it goes. There, that's feeling pretty good. Looks like everything's kicking off the right way and trailing out. All right, now let's add in our particles again, and let's see what happens. So let's turn these guys back on. Let's see if they are kicking in at the right time. There we go, and then they sprinkle out. RZ, let's see. All right, so I don't want them to come on after the erosion happens, but I don't want them to come in right there. I want them to come in right when the second part of it pops. It goes up, boom. So it's just mistimed slightly. Let's increase our delay to, let's try 1. We're going to over-exaggerate it a little bit and see if that's too long. Yeah, that's too long. So let's go to 0.75. And we'll just decrease from there. I think that's going to be around what we need. Okay, that's not too bad. Yep, they come on right when we, okay. So timing is looking really good for that. And if I run, that's good. Also, these are kind of bouncing too high. Let's go into our collision settings. This will be kind of a final thing. And friction during a bounce, let's turn that up to 1. And you can play with the restitution and the friction during bounce. But let's change our friction to 1. And our restitution, let's put that to like 0.1. Let's see what happens. There we go. See, yeah, that's cool. There, they're kind of melting into the ground. That's really cool. I like that. So basically, I'm just restarting and I'm running off the platform. So again, that's why it's nice. See our character, I can jump, but my material still stays on because of our world position setup. So we're not jumping out of the material. But I think that's all looking really good. If I were just to let this sit, respawn in, everything kind of fluctuates. We might be able to boost the emissive intensity of the the scrolling energy, just a little bit. You can come back here. Let's double it for now. I like to over exaggerate and then you can dial it back. That might match color a little bit better. And it kind of fades over time. I think that's all working really well. Nice. Now, last thing to check before we're done is our MPC for our master parameters. Let me exit out of this. Let me just make sure I save everything that's not saved. You can just file, save all, and save the map. And let's come back to our global Scififx. Let's just make sure our respawn color can change all of it. This will make sure everything's hooked up correctly. Boom. Okay, so everything is hooked up the way it needs to be hooked up, and now our master color change parameter can be run. One more thing, if I hit F11, I can bring up full screen and we can just see this in all its glory. All right, let's just go ahead and make sure we get that red color back to our blue. And let's just save it and make sure it's working. There we go. All right. Great job, great work. Next section, we're going to jump into our ammo pickups and get those kicked off. And I'm looking forward to tackling that with you guys. Alright, now that we've finished our respawn effects, I just want to challenge you to take things to the next level. Take what you've learned in this part of the course and rearrange the effects a bit. Create something new, create something that is unique to your personality, your style, put your own flavor in it. Maybe it's just changing colors around or changing the way the energy pushes into the character. Maybe it's just a cylinder that wraps around the character with energy scrolling up through it to represent the character spawning in instead of that flat platform base that we created. Whatever it is, take the practices that you've learned in this course and craft something that again is just unique to who you are and the sense of style and effects that you want to pursue. So that's the challenge, just a quick assignment to really take this to the next level and have something that you can demo on your portfolio. And as always, with any of the effects you're going to create in this course, I would love to see what you're making, so please feel free to share. All right, I hope you have a blast, and I hope you create something new and unique, and I can't wait to see what you're going to do with your own respawn effects.